Good morning. My name is Alaa Kamil, and I'm serving as the designated federal official to the U.S. EPA Science Advisory Committee on Chemicals, SAC. For this meeting and in my role, I will be opening the third day of the public meeting on the Science Advisory Committee review of EPA's draft risk evaluation for octamethylcyclotetrasiloxane D4. I would like to repeat that SAC meetings are subject to all requirements of the Federal Advisory Committee Act, FACA, and these include opening meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov listed in the agenda. As a reminder, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube, and you may access the link through the D4 peer review webpage also listed in the agenda. I would like to thank Dr. George Cobb for facilitating the sessions in the past 2 days, and Dr. Mary Fox for facilitating the first session in yesterday's meeting. I would also like to thank the committee members and the ad hoc reviewers for their responses to the charge questions. And now I will hand it over to Dr. George Cobb to start today's discussions. Dr. Cobb.
Thank you, Dr. Kamal, and welcome everyone to our third day of this D4 review by the Science Advisory Committee for Chemicals. One point of housekeeping: yesterday afternoon, after we adjourned, we met to discuss quorum matters with relation to a possible meeting tomorrow. It looks like we are unlikely to have quorum, so we will try to finish all of our discussions and deliberations today. I should also point out that while quorum was not met during the discussions I'm getting ready to mention, some of the committee members did discuss things that really have already been discussed here: the need for EPA to be clear about which parts of the documents that we have reviewed and are stated that they were reviewed by us and used in this assessment, which parts of our comments had not been incorporated. We also discussed the difficulty of locating information in the 30,000-page ECA report and some possible solutions to that. But nothing necessarily of substance that I don't think we've already covered, but just for completeness, I think it's good that we get that out of the way. So now let's move to our roll call, and Dr. Apti.
I'm here.
Dr. Baker.
I'm here.
Dr. Chason.
I'm here.
Dr. Ike.
Good morning. I'm here.
Dr. Fox.
Good morning. Here.
Dr. Graham.
Cynthia Graham is here.
Ms. Jenkins.
I'm here. Good morning.
Dr. Lee.
I'm here. Good morning.
Dr. Merced Nieves.
Present. Good morning.
Dr. Ottinger.
Good morning, everyone.
Dr. Prisbilla.
Good morning. I'm here.
Dr. Sama.
Good morning. Here.
Dr. Wright.
Good morning. I'm here.
Dr. Fairbrother.
Good morning. Here.
Dr. Johnson.
I'm here.
Dr. Osmond.
Present.
Dr. Rowlands. Dr. Wyckoff.
I'm here.
Right. And Dr. Chung was maybe not going to be here. Okay. And then go back to see if Dr. Rowlands is here. All right. Well, I think we have our quorum, and so now we can proceed to our meeting agenda. And as we generally do, I'd like to circle back and see if anyone has comments about the things we talked about yesterday, additional things that were considered over the evening that we should get into the record here from the committee. Okay. Dr. Johnson.
Yeah, I'm sorry, I can't turn my camera on right now. It's disabled. But just one point I think that we kind of talked about, just to get it on the record, in reference to the scatter diagram, it would be very useful to have the point of departure based on plus or minus one standard deviation, the 5% BMDL, and maybe even a Bayesian 5% BMDL, just to see how the variability affects those points of departure. It would be very useful to see that in the spatial context. And that's all. Thanks.
Great. Thank you for that comment. Other comments from the committee? I did have one clarification related to some things we talked about with sediments yesterday. I mentioned a hard surface, rocky bottom surface that might have influenced some of the sediment data and the D4 concentrations in sediments relative to where those sediments might have been collected and how they may have come to equilibrium with the water column. And I looked back at that report last night, and the sediments that I can discern from the report that had the rocky bottoms were not the ones where the industrial effluents were collected. And so that's probably not a reason, unless I've missed something. I'm going to continue to look at that and make sure I've got that right. Also, I did notice this time, though, that I didn't notice in the last read, that some of the sediment sampling areas were influenced by dredging in the reaches of the river that were being sampled. And that certainly could have influence on what kinds of chemicals are in the sediments and where sediments are depositing or redistributing themselves. So those are items that we need to consider in the report. And I'll get that information to the folks that are writing about stuff. Okay, let's turn to EPA to see if there are any clarifications from yesterday before we go into the charge question.
This is Chris Green with EPA. Good morning. Morning, everyone. So on the human health comment that we just heard, I do want to point out that I don't have any clarifying question on that received, so to speak. So thank you very much. I do have a clarifying question from you, Dr. Cobb, just to talk to you about the different sites for DD1, 2, 3, and 4, just as a curiosity for myself for clarification. The hard bottom, would that be the Raisin River in Michigan by chance? Or do you recall? Just this is a clarifying. I was just curious because I poured over that extensively as well. So
I'm
just
sorry,
curious.
I don't have that right at the tip of my at my fingertips, and I just went off of that area of the report to go to a table to see if I could find more information that I couldn't. So I lost my place in the report where I was looking. But as I remembered, the rocky bottoms were in what I saw were in sites that were not these industrialized, the streams where the wastewater was coming from an industrial source. But if you have information that's somewhat different than that, I would be happy to hear it.
I do not, but I was just curious if you could recall, oh yeah, that was River Raisin, or that was the Hudson River or the Ohio. I just figured if it was on the tip of your tongue, it would remind me as to what you were talking about to center in. So thank you, though. And this is Chris Green from EPA.
Dr. Green, I can circle back to that before the morning is over.
This is Chris Green with EPA. Thank you. That's great. Cool.
Okay. Thanks for that dialogue. And now we can move to charge question 7. And if we can get that into the record, and then we'll start with the response.
Good morning, this is Jim Brissett from EPA. Charge question 7. A survey of the bioaccumulation metrics for D4 are presented within the draft physical chemistry and fate assessment for octamethylcyclotetrasiloxane, D4, media concentrations of D4 and potential sources of uncertainties are reviewed within both the draft physical chemistry and fate assessment for octamethylcyclotetrasiloxane, D4, and draft environmental media and general population exposure assessment for octamethylcyclotetrasiloxane, D4, section 3.6 of the draft physical chemistry and fate assessment for octamethylcyclotetrasiloxane, D4, details bioaccumulation potential of D4 while concentrations within the aquatic species, terrestrial species, and biotransformation are reviewed within section 3.1, 4.1, and 5 of the draft environmental exposure assessment for octamethylcyclotetrasiloxane, D4, respectively. Next slide, please. Well, I just changed. Charge question 7A. Detailed within the draft physical chemistry and fate assessment for octamethylcyclotetrasiloxane, D4, BAF is typically preferred when estimating human exposure to a chemical from fish ingestion because it considers the animal's uptake of the chemical from both the water column and from the diet. However, there are considerable uncertainties associated with the field measured BAF values available for D4, e.g. low detection frequency, unpaired fish water field samples. EPA believes that the laboratory measured BCF data set is more robust. Moreover, D4 intake rates from dietary routes are low because D4 undergoes appreciable biotransformation in the gastrointestinal tract of fishes. For review, see section 5 of the draft environmental exposure assessment for octamethylcyclotetrasiloxane, D4. Please comment on EPA's use of a BCF in lieu of BAF to estimate D4 concentrations in fish tissue and evaluate human exposure through fish ingestion and the strengths and uncertainties of this approach.
Right. Thank you for getting that into the record. And now we can go to our discussants, and the lead for this is Dr. Ottinger.
Thank you very much. And thank you to EPA for extensive prep for this charge question. So in summary, the bioconcentration factor, BCF, and bioaccumulating factor, BAF, are indicative of high bioaccumulation potential for D4. Conversely, biomagnification potential, BMF, TMF, appear to be low in laboratory and field studies, which is explained as differences in exposure routes and biotransformation rates. However, the conclusion, lines A51 to A52, that biotransformation negates the risk for adverse effects of D4 is an error. We will give sufficient explanation for this and other points below. So beginning with these points, in a sense, EPA's question about the validity of using BCF instead of BAF to calculate fish tissue concentration from water concentration is moot. EPA showed that the maximum measured fish tissue concentration from the ECA study results in an MOE well above the 30 benchmark for all consumer and tribal exposures to dietary fish. Therefore, there is no need to do the modeling based on estimated or modeled discharge water concentrations. That said, the logic of using BCF as an upper limit of water to fish uptake is sound if it is done using stable state values. As EPA noted, the dietary portion of the total uptake is known to be significantly less than that of gill exposure and may not add a significant portion to the total body burden. Additionally, it is possible that the laboratory exposures force greater gill uptake than is seen in natural systems, as most of the studies are conducted with closed headspace, thereby reducing volatilization and increasing the water concentration. This would result in a conservative, in other words, higher, calculated BCF as compared to natural systems. However, the BCF estimates that were made from dietary-only exposures and then estimating water concentrations from which the BCF is calculated could result in lower than expected values due to biotransformation processes in the GI tract. All these studies are described in pages 40 and 41 of the draft physical chemistry and fate assessment document, which ends by saying the BCF was derived only from the BCF SS studies, those with water exposures only, without saying why the others were excluded. While agreed that they should be excluded, EPA should present their reasoning in the document. Environmental BAFs are lower than lab-derived BCF values, Guo et al. 2021 and Wang et al. 2021. This suggests that EPA's usage of the average lab BCF results in a conservative exposure estimate and underscores the advisability of using maximum field measured fish tissue concentrations instead. Going on to additional comments, estimating D4 exposures using conventional means such as BAF is not straightforward. Given that D4 is primarily lipid with limited water solubility, exposure in aquatic organisms is likely a consequence of water fraction and adhered organic fractions, meaning particulates, and a multitude of other factors in water. That studies have shown a very small proportion of D4 is absorbed via the GI tract in fish, less than 13% from Cantu et al. 2024. Using the non-diet BCF seems reasonable, yet there should be recognition of the variability that would be realistically expected. Agree with the comments from Dr. Gobas that EPA should also use the output from various models and compare those values with those calculated from controlled laboratory studies and examples of various biota in freshwater and marine environments where body burdens have been reported. The latter data could also be used to estimate exposure since a TMF could not be demonstrated, and that's citing Gia et al. 2015. Additional comments. The use of BCF in lieu of BAF is consistent with the screening level analysis conducted as described in the draft Environmental Media and General Population Exposure TSD. For a screening analysis, it is appropriate to use inputs that reflect higher exposures, meaning overestimates, with the understanding that if the risk characterization indicates an increased risk in a refined analysis is conducted. The strengths are that a screening analysis is a health protective approach using data that may overestimate in situations where data availability are limited. It seems to have served this purpose. Fish ingestion does not appear as a driver of unreasonable risk in the draft DRE. BCF should never be used in lieu of BAF unless there's clear evidence that waterborne uptake outweighs diet in the fish of interest. In theory, BAF should never be lower than BCF because BAF integrates diet, but BCF does not. However, in practice, the measured BAF can be lower than a well-designed BCF when studies are small, not at steady state, or have diet composition uncertainties, such as exactly what we see in Wang et al. And in Gao et al. For D4. And the references to figure 3.5 on page 43. We should keep in mind that there is no universal BAF for D4. It varies with site-specific water versus diet exposure. In the meantime, the difference between BCF and BAF can also be minimal if a chemical has low dietary uptake efficiency and/or undergoes substantial intestinal or first-pass biotransformation. However, the above counterexamples do not justify replacing BAF with BCF. They simply highlight data quality and design issues in the field BAFs and the need to analyze them with appropriate censoring/weighting rather than redefining the metric hierarchy. Also, as Dr. Frank Gobus emphasizes in his public comments, BAF depends on the relative concentrations in water and diet. So if prey concentrations are high, diet can still dominate even with lower uptake efficiency or fast intestinal or first pass biotransformation. The SAC believes that in this specific D4 case, although using the maximum BCF values happens to be more protective than using BAF values, presenting this in the report may seem to be a bit problematic. This may be misinterpreted as setting a methodological precedent for doing such a replacement in future chemical assessments. This may also potentially promote the misuse of BCFs. The committee strongly recommends that EPA clearly states this as a practical choice, not a general principle in the report. Rather than substituting BCF for BAF, EPA should adopt mechanistic scenario-based bioaccumulation modeling, using models such as the ADME-B model already adopted in the report, with a calibration to reliable lab kinetics, using datasets that support high confidence BCF values identified by the EPA, and also explicit considerations of different scenarios characterized by those highly variable inputs such as diet. This should not be impossible given that the EPA has already used the ADME-B model to determine BCF values under different scenarios of DOC levels. Using mechanistic scenario-based bioaccumulation modeling will help avoid apples versus oranges, for example, mixing of field and lab metrics, and prevent a precedent where BCF is used simply because it's larger and seemingly protective than an uncertain BAF. As such, the committee's recommendation is to use BCF as BAF only when you first show that water dominates diet for the fish and setting at hand, otherwise model the BAF. A few specific comments. The EPA considers BCF dataset more robust. However, biotransformation of D4 in the fish GI tract diminishes the concentrations of D4 in fish tissue. Are the metabolites produced bioactive? And if so, do the models consider these additional chemicals, or is this an additional source of uncertainty? On lines A51 to A52, the conclusion that metabolism of D4 in the GI tract precludes significant accumulation from dietary exposure ignores the metabolites, which may also be bioactive. See, we reference some studies. And the D4 transformation products, which seem to be written off either because of lack of studies or less potent effects, should be considered. Domorowski et al. 2017 tracked radioactive D4 and reported a high proportion of parent compound D4 in the tissues. However, liver showed more transformation products. Do laboratory and field studies consider potential bioactive metabolites of D4 or bioindicators of activation of toxin-related physiological responses, meaning liver enzymes, etc.? In addition, radioactive tracking studies may not separate D4 from transformation metabolized products. And this means that assuming that the radioactive recovered numbers are only D4 may be an error. A similar study in juvenile rainbow trout showed negligible transformation, except for liver and GI tract, which contain metabolized. Accordingly, it's important to evaluate transformation products that may occur in the various media, meaning water, sediment, etc., as part of the overall model, as some of the disconnect may be due to an incomplete characterization of the parent and transformed/metabolized compounds. In addition, the most accurate estimate of D4 concentrations in fish tissues should be used in probabilistic exposure models for total daily exposures. And that concludes reading in our comments.
All right, thank you for getting that into the record, Dr. Ottinger. And now we can turn to our associate discussants, and the first is Dr. Fairbrother.
That was well done. Thank you, Marianne. I don't have anything to add.
And Dr. Fox?
Yes, thanks. Nothing to add.
And Dr. Johnson?
Yes, thank you. Nice job. Nothing to add also.
All right. And the rest of the committee members, are there any additional comments relative to this charge question? Dr. Lee.
Okay, good morning. This is Lee. So I just want to make some general comments. Maybe these comments is just like my personal opinion, but I want to read it into record. So the general comment is on, it's about whether BCF or BAF should be used. So basically, I think whether BCF or BAF should be used should be dependent on the purpose of why this metric is used. So number one, so EPA substitution of BCF for BAF is only appropriate if the purpose is for a screen level hazard designation. For example, if we want to do a quick PBT screening of the chemical. And in that case, a water to fish metric should be enough if we don't have detailed risk assessment information, but we want to do a quick decision. And number two, but when the goal is to estimate the fish tissue concentration and human exposure through fish ingestion, especially for PESS, this is actually what the EPA is doing. The choice of metric must be scenario specific and relevant to the path. So this even goes beyond the issue whether BCF or BAF should be used. So in my opinion, randomly picking a BCF or BAF, no matter whether the maximum value is used, whether you are high enough, of course, being high enough is good, but this is not a scenario specific or not relevant to the PESS we are talking about. For example, because BAF integrates both water and diet, relying on BCF alone may be underestimating the exposure for PESS, especially in the ecosystems where the pre-concentration or diets drive the uptake of chemicals by fish and human take the fish. So for exposure estimate and risk characterization, EPA should prefer a mechanistic modeling that use the BAF or BAF equivalent tailored to the local diets, bioavailability, the food chain structure, and the fishing patterns. So that can be more relevant to the PESS we are discussing. Okay, so that's my general comment.
Thank you, Dr. Lee. Are there other comments or follow up to Dr. Lee's comment?
I'd like to follow up and emphasize that those models must include the transformed or metabolized products as well. And you've heard that through the comments, but I think what Dr. Lee has said really bears emphasis, especially when we're considering PESS populations.
And I might add, I think Dr. Lee was not part of this charge question because we thought we were getting to this tomorrow, and I don't think you're able to join us tomorrow. So I appreciate you being here and having the comment.
Actually, he is part of this charge question.
Yeah, this is Lee speaking. So actually, I submit some comments on this. Yeah, so actually, Mary and Dr. Ottinger has done a very good job in incorporating my comments. I just made this general comment, which is not relevant, specifically relevant to this question.
Sure. I was talking about the associate discussants that I have listed here. And if that's an error, I apologize. Okay, any other comments from the rest of the committee? All right, turn to EPA to see if there are any clarifying questions regarding the response.
Jim Brissett, EPA, we have no clarifying questions.
Excellent. So this is George Kopp speaking. Before we go on to 7B, I'd just like to circle back to the question that was posed to me about the different sites that had the hard bottom, that at least the ones that I've seen so far. They were on page 47 of the ECA report, and they are I-4. I believe that was in Oregon. I-5, I think that was Chicago. And then R1, I can't remember where that one was. So those were the three sites that I saw identified on page 47 of the ECA report. Hope that didn't break up the flow too much. And now we can turn back to you for getting us charge question 7B.
This is Jim Brissett, EPA. Thank you, Dr. Cobb. Yeah, those sites were control sites.
No, they weren't. They was just thank you for clarifying that.
Thank you for the clarification. We'll move on. Charge question 7B, part 1. 7B, section 3.6 of the draft physical chemistry and fate assessment for octamethylcyclotetrasiloxane D4 details many sources of uncertainty in field and laboratory-derived bioaccumulation metrics resulting from the study's design. Water samples for BCF and BAF studies should be analyzed to capture the bioavailable fraction. However, this can be difficult for D4 because of its volatility, hydrophobicity, and low water solubility. Furthermore, field studies introduce uncertainty when controls are not collected. Sample sizes are small, steady-state conditions cannot be confirmed, and specific D4 contaminated food consumed by the fish is unknown. Although field measurements sometimes provide a more representative picture for accumulation dynamics in natural environments when compared to engineered laboratory settings, bioaccumulation metrics can also be skewed if low detection and quantification frequencies in the sampled biota are not taken into consideration. Because of the different uncertainties and strengths between laboratory and field studies, Bioaccumulation metrics from both were considered in EPA's overall analysis of the bioaccumulation potential for D4. Considering the inherent uncertainties associated with quantification of D4 in media and biota from field studies, as well as differences in the ability to control for exposure routes and concentrations between laboratory and field studies, please comment on the strengths and uncertainties of the selected data used for EPA's assessment of bioaccumulation metrics.
Thank you for getting that into the record. And now we can go to Dr. Ottinger is again our lead.
Thank you very much. Okay, in summary, then I'm going to provide some summarizing statements and then go into a little bit more of the discussion. So in summary, the use of bioconcentration factor BCF reflects D4 uptake by aquatic organisms directly from contaminated water, generally via gills and not by diet. However, attempting to estimate BCF in studies resulted in 3 excluded studies due to exposures greater than D4 solubility, small sample sizes due to fish mortality, that's the Dow Corning study 1992, experimental design issues, and that's Z et al. 2019-2020, dietary D4 studies that could have variable dissolved organic matter in the water to which D4 could adhere. Regardless, there are some BCF values that appear to be comparable, and that's Fackler et al. 1995. Studies with BCF and BAF ranges shown in figure 3-5 on page 43 of the draft physical chemistry and fate assessment for D4 provide a more direct comparison of bioconcentration and bioaccumulation data in fish, illustrating large variation potentially due to the multiple factors influencing uptake. Given the uncertainties in the aquatic biota data collection without co-located water and sediment data, a BCF based on those data would be uncertain. The use of BCF rather than BAF is well justified, yet the uncertainty stems from a lack of release data, transfer, and analytical environmental media data. The variability stems from site-specific conditions that can affect body burdens, including organic carbon content, pH, temperature, etc. Without the collection of more data, there are few alternatives other than a more detailed uncertainty analysis checked with other models comparing those results with analytical body burdens. There's an initial recommendation that I'll emphasize later, which is to consider a side-by-side comparison in a table comparing modeled biota estimates with available collected data, such as section 3.1 in the draft exposure assessment. Assess the variability in those data, consider the use of other models to estimate bioaccumulation, BCF, as those stated in the comments from Dr. Gobus. In addition, additional summary comments state C response to question 7A, and in addition, it is appropriate to not use the studies where exposure doses are greater than D4's water solubility, and that's on page 40, Dow Corning 1984, Springborn 1249, Laboratories 1991 D and E. EPA's review of other BCF studies appropriately identified their limitations. See pages 40 and 42. The 2 field studies cited in Table 3-1 of the draft Physical Chemistry and Fate assessment for D4 for estimating BAF for D4 are limited in their applicability. They are both the same species, meaning carp, and analyzed only mussel, not whole fish. EPA correctly noted that this is a significant limitation as fish species vary in their percent lipid size and metabolism. Page 45 cites 3 high-quality laboratory studies where fish, including rainbow trout, were fed D4-containing diet and a BMF was calculated when at steady state. It is not clear why EPA did not include Woodburn et al. 2013 and Compton 2019 studies in the calculation of the BCF in Table 3-1, similar to the Cantu 2024 study. Additional issues were identified in terms of strength. The committee commends EPA for its transparency in articulating the analytical challenges and sources of uncertainty in determining D4's bioaccumulation potential. That would be in section 3.6.6 of the draft physical chemistry and fate assessment document. The committee also appreciates EPA's decision to exclude 3 studies that reported aqueous exposure doses exceeding D4's water solubility, lines 1248 to 1249 of the draft physical chemistry and fate assessment document. This is a defensible choice because such tests are likely to fail to represent the dissolved bioavailable fraction. The committee also notices that this exclusion narrows the usable data set and increases the weight placed on the remaining studies. In terms of uncertainties, the committee raises concern with the lipid normalization of measured BCFs used to derive a representative central tendency BCF, lines 1307 to 1311, and Appendix B2. While it is true lipid normalization, while it is true lipid normalization has historically been applied to some chemicals, it is not mechanistically appropriate to assume BCF scales with lipid content for all substances, especially those for which there is no evidence that they partition predominantly into the fat tissue rather than into other tissues. In particular, in the case of D4, table in the Appendix B1 clearly shows that no clear correlation between wet weight BCF and lipid content, indicating lipid is not the primary driver of BCF. Therefore, applying lipid normalization to D4 BCFs is not substantiated by available evidence. In addition, even if EPA intends to apply lipid normalization to D4 BCFs, it's important to ensure that both the lipid content and the BCF values are derived from the same test population. Currently, the lipid content used to scale 2 data points from Dow Corning 1992 and Dow Corning 1993A, see table Appendix B1, are drawn from studies published in 2007 and 2024. These later studies may not accurately represent the lipid content of the original test populations, which may introduce potential inconsistency and uncertainty into the normalization process. The committee recommends that EPA adopt mechanistic scenario-based bioaccumulation modeling to drive a representative central tendency BCF rather than pooling literature-reported measured BCFs together and scaling them by lipid content. Instead, measured BCFs should primarily be used to evaluate model performance. In fact, the SAC notes that EPA has already demonstrated this approach using the ADME-B model and noted that the semi-empirical ADME-B BCF of 8,429 liters per kilogram agrees well with the central tendency of the empirical values, of which the arithmetic mean is 8,795 liters per kilogram, lines 2,694 to 2,695. EPA should consider applying the model derived value for decision making. Finally, when using the literature reported measured BCFs to evaluate model performance, the EPA must explicitly weight data quality. For example, although the draft physical chemistry and fate assessment document clearly acknowledges significant methodological flaws in Z et al. 2019-2020, see section 3.6.1, those measurements were still included in pooled summaries in Appendix B.2. The SEC strongly recommends that EPA reevaluate data quality and exclude or downweight flawed measurements before using them to support regulatory conclusions. There is an additional recommendation, and then I'll give a couple of specific comments. The additional recommendation is consider a side-by-side comparison in a table comparing modeled biota estimates with available collected data, and parens from section 3.1 in the draft exposure assessment, end of parens. Provide qualitative statements or indications regarding the general magnitude and direction of how the calculated value likely represents reality. A couple of specific comments in line 243 to 246 of the draft physical chemistry and fate assessment for D4. Rapid hydrolysis of D4 to DMSD, a metabolite, is predicted in an aquatic environment, varying with pH and temperature. This raises the question of potential adverse effects from DMSD and the uncertainty of potential concentrations of DMSD in aquatic environments. Although the application of sludge and other sources of D4 to soil, models show that DMSD is produced and also volatilizes under drying conditions, possibly contributing to deposition in streams, and that would be Ramanathan and al. 2012. DMSD was found in water in sequestered system, ISS, from cosmetics and other personal hygiene products, Muirhead and Carter, 2018. This example shows release of an active metabolite that could also contribute to DMSD in landfill and wastewater. This is uncertainty due to removal processes. There is uncertainty due to removal processes in wastewater operations, and few data are available about this metabolite. However, there is evidence from laboratory studies for adverse effects of DMSD on liver, blood cells, and possible neural systems. And that's Ramanathan et al. 2012, SCHSC 2007 and 2009. Finally, it seems that on tables on pages 79 and 80, those repeat information on pages 76 and 77, but also are relevant to the content discussed on those two pages. And that ends our comments for this charge question.
Thank you, Dr. Ottinger. And now we can turn to our associate discussants. And I'm sorry, I have too many windows open. Dr. Fairbrother. No, yes, Dr. Fairbrother.
No, I don't have anything to add. Thank you very much.
Dr. Johnson?
And nothing to add from me either. Thank you.
And Dr. Lee?
Nothing to add. Thank you.
And now turning to the remainder of the committee, any additional comments? If there aren't any, this is one place where there's some crosstalk with our response to charge question 5. I'm still not convinced that the data that are termed below quantification are actually below quantification. I think some of those data may actually be quantifiable. Regardless of that, as I think I mentioned yesterday, if there are data that are below the quantification level and you can estimate those by any number of methods, and you get different answers depending on whether you use the limit of quantification or a 0, that tells you that your method's not adequate for the task at hand. And so that kind of sensitivity analysis can pretty quickly be done to help get to answering some of these questions. Dr. Ottinger, I see you back on the screen.
Yeah, if I could add to that, one of the areas that I know I was emphasizing was that of the transformation products. And the question is if the methodology includes or does not include. In other words, I'm asking a question about the specificity of the assays being used. that needs to be discerned very carefully, and one might argue either direction, either make it very specific for D4 or make it inclusive of D4 and metabolites that are produced in the environment or in the animal for that matter.
Something like a total toxic residues, if you will.
Right, because of the bioactivity of that particular metabolite seems to be the primary one that's produced.
Okay. And Dr. Ottinger, I'll make sure you have those comments. I think I gave them to Dr. Chung for charge question 5, but I'll send them to you with a note that we already have them in charge question 5.
Thank you.
Okay, EPA, any clarifying questions regarding that response?
This is Jim Brissett, EPA. Yes, we do have a clarifying question to ask. As far as the data quality, I believe it was reference to BCF, and what specific studies were we being asked to reconsider? If those could be sent to us as soon as practicable, that would be great.
I think there's several of us that have contributed a number of references, but I believe Dr. Lee, you had some references?
Yeah, so this is Lily speaking. Yes, I did mention two papers, maybe one paper or two papers, as XUE et al. So the first name of the author is the XUE. In 2020, 2019 and 2020. So actually, I find that 2019 may be the original paper that published the data, but then the author also published a correction in 2020. But in the report, both papers were cited.
Okay, I don't currently have that in our compiled summary, so if you would provide that, that would be great.
Oh, it's mentioned. It's mentioned there.
I meant the actual reference.
Oh, right.
So, and actually, Dr. Ottinger and Dr. Lee, if y'all can collaborate sometime today, and maybe before we're done today, have one summary document that has the studies listed.
Yep.
And either we can present them as a shared screen, or Dr. Kamal can get them loaded for you. That will help EPA immensely in getting their response started before we can finish our full document.
Yeah, Dr. Lee, if you just add that to our compiled document, that would be fantastic.
Oh, actually, that paper was already in the report. And also the report also analyzed the methodological flaws in the report. And then after that paragraph, even if they know the flaws, this paper was still included in the further analysis. Yeah, so that's why I put that into the comments.
Okay. Yeah, if you would just add that on to the reference list, that would be fantastic. Thank you.
Mm-hmm. Okay, thank you.
Okay, and EPA, would it be helpful to have that list of references like I provided yesterday from this particular output as well?
Jim Brissett, EPA, yes, that would be very helpful. Thank you.
Yes, trying really to get you guys a leg up on responding to the comments. So yeah, and thank you for that dialogue, that question, and now we can move on to our next part of charge question 7.
Jim Brissett, EPA, charge question 7B, part 2. Please comment on the strengths and uncertainties pertaining to EPA's preliminary conclusion surrounding biomagnification metrics.
And now we have Dr. Johnson.
No.
No.
Me again.
Oh no, I'm sorry, Dr. Ottinger again. You're pulling yeoman's duty today, Dr. Ottinger.
This is it for me. Okay, would you like me to proceed?
Please.
Okay. In summary, the SAC appreciates the extensive review of available data in the literature pertinent to this charge question. The preliminary conclusion about uncertainties related to biomagnification metrics has merit, especially given the variability of information from field studies. That said, it is not entirely clear that field studies should be considered not considered, sorry, when determining biomagnification and the use of laboratory studies, which are providing foundational information under the more controlled conditions. The public comments submitted by Dr. Frank Gobus highlighted uncertainties associated with the less reliable, low-quality data points, meaning small trophic span, inadequate sample sizes, and incorrect use of lipid normalization, BMFK values, whereby he further argued the importance of selecting only high-quality data for further improvement of biomagnification assessment. Additional analytical approaches are suggested for consideration by the EPA. Additional comments are included in our charge question discussion. So in summary, the strengths supporting EPA conclusions regarding the probability for biomagnification reside in some key studies where multi-compartment models were used in fish, meaning Cantu et al. 2024. In this study, 22% was eliminated via feces and not absorbed. 62% was biotransformed in the GI tract or gastrointestinal tract. 16% absorbed, and 10% of this is biotransformed in the body, and 6% bioaccumulation. This supports the lack of biomagnification of D4 from aquatic exposures and likely is relevant for transfer to the terrestrial environment also, as often many of these same microflora and digestive enzymes are conserved across species. The field data for D4 body burdens collected from other species are not robust, but generally supports this conclusion. In another set of comments, EPA asserts that while BMF may be estimated from field measures or measurements, controlled laboratory experiments allow for the following conditions of an accurate BMF determination to be confirmed, meaning that steady state is reached, diet is the sole source of exposure to the predator, and that a consistent chemical dose to the predator is maintained. See page 45 in the draft Physical Chemistry and Fate Assessment for D4. EPA leaned heavily on laboratory studies and excluded most field studies when determining aquatic biomagnification metrics, and that's on page 47. EPA posed that field studies are more uncertain, meaning less reliable, because of small sample sizes, uncertainties around diet, multiple exposure routes, unknown steady-state conditions, and low concentrations, meaning high percentage of non-detects. EPA did not list the uncertainties of laboratory studies, which might include unrealistically high exposures, abnormal diets, such as laboratory fish food, with differing lipid concentrations, non-steady state conditions, small sample sizes, or incorrect replication, non-representative water temperatures, among others. Although EPA states that both laboratory and field measured bioaccumulation metrics were considered in the overall analysis of the bioaccumulation potential of D4, they obviously favored lab-derived values. It is noted that field-derived values, as they are more representative of the conditions, temperature, organic carbon, lipid concentrations, that would be encountered in real-world situations. Some studies did not parse out trophic relationships using isotope tracking, for example, Dow Corning 2009. While concentrations in a river or lake, may vary over time, this is not likely to occur quickly due to sediment load. So it can be assumed that fish are at steady state, meaning exposed for approximately 21 days. Laboratory studies can provide insights into processes, contributions of different exposure routes, etc. But if lab-derived values differ significantly from field-derived values, the field-derived values should be given preference. Note, this is what EPA eventually did when assessing risk from fish consumption, defaulting to measured values from the ECA study. It'd be very helpful and enlightening for EPA to tabulate the biomagnification metrics, meaning BCFs, BAFs, and BMFs from all field studies to see how they compare to the laboratory values. Another set of comments include the following. EPA's preliminary conclusion that D4 does not biomagnify is generally supported by the better quality evidence. First, the draft physical chemistry and fate assessment document synthesized literature reported values and showed laboratory dietary BMFs less than 1 in all 3, high quality, the term used by EPA in line 1459 in those studies that follow OECD test guideline 305. Second, the draft physical chemistry and fate assessment document acknowledges that some field TMFs greater than 1 occur, but are relatively close to 1, line 1527. Similarly, the draft environmental exposure assessment document finds that mean TMF for aquatic biota from 7 studies with medium and high data quality was 0.79 with a range of 0.31 to 1.4, and that's in line 590, with only 2 measurements suggesting a TMF greater than 1. More importantly, the draft environmental exposure assessment document clearly states that 2 TMF greater than 1 measurements are not statistically significant, with a p-value of 0.16 and a p-value of 0.23, respectively, in lines 599 and 600. Therefore, the above lines of evidence also favor no biomagnification. The committee appreciates this detailed analysis of statistical significance in the draft environmental exposure assessment document. However, it is unfortunate that this analysis does not appear in the draft physical chemistry and fate assessment document as well. The committee also notices and concurs with public comments by Dr. Frank Gobus. In his comments, he correctly pointed out uncertainties associated with less reliable, low-quality data points, meaning small tropic span, inadequate sample sizes, and incorrect use of lipid normalized BMFK values, whereby he further argued that the importance of selecting only high-quality data for further improvement of the biomagnification assessment. The committee recommends EPA adopt these comments. Couple more comments. As captured above, the variation in field collected samples result in uncertainty in determining biomagnification metrics, with many influencing factors such as uncertainties related to environmental conditions, bioavailability, source, distance, and concentrations of D4 in aquatic waters, solubility, and transformation products. All are important in assessing the true risk to living organisms. As shown in Table 3-3, page 25, and discussed in Section 3.3 of the Draft Physical Chemistry and Fate Assessment, the half-life of D4 is also a factor in the environment. Accordingly, data are needed to address the potential trophic factors from transformed products and if these chemicals, in addition to the parent compound D4, exacerbate potential effects from exposure. If the parent compound and transformed products are considered, then discernible biomagnification may occur. Further, the strength of laboratory studies is to control variables to the extent possible. As such, it is important to conduct these more controlled studies and then compare to outcomes from field studies and identify the factors that add uncertainty in the field. Further, modeling and analytics suggested by Dr. Frank Goebel in his public comments on December 2nd, 2025, should be considered by the EPA. another set of comments. The work in the BMF portion of the PChem document is good but could be improved. EpiSuite modeling can be improved to better estimate D4 fractions and half-life in compartments. EPA has modeled D4 releases to air and soil and has measured or modeled D4 releases to soil. An added factor of releases from consumer products can be obtained from studies of air in Chicago and New York City. These values should be added to the airborne release amount. With these data or estimates, discharges to each compartment can be expressed as mass per time and entered into EpiSuite to better estimate D4 releases and thus improve the model estimate of D4 behavior in the environment. Further, the discussion of BASFs is erroneous. A BASF is by definition the ratio of lipid normalized contaminant concentration in tissue divided by organic carbon normalized contaminant concentration in sediment. So the lines 1395 to 1396 cannot be correct. That sentence states that BASF measured by Kent 1994 was not lipid or OC normalized. Line 1417 suggests that BASFs are above and below the 1.7 threshold. However, UCL 90 and UCL 95 of each BASF is above the 1.7 threshold, suggesting that D4 bioaccumulation is likely in the environment. Using values below UCL 90 or 95 would be inappropriate. For specific comments, what is the extent of soil and air monitoring data for D4? The table on lines 247 of the draft environmental, media, and general population exposure for D4 includes a statement comparing modeled D4 concentrations in soil and in air to monitored concentrations. It is unclear what the monitored concentrations are. And finally, line 287 of the draft environmental, media, and general population exposure for D4, the EPA claims to have used available information about releases, but the occupational exposure document does not contain any monitored data that describe releases to air from manufactured facilities. If there are no actual release data, that must be stated. Further, the statement regarding the environmental testing report must be rephrased to indicate that the report included monitoring of water sediment and select aquatic biota. The correct wording could be misconstrued as indicating that D4 concentrations in air and soils were also evaluated, which they were not. And that concludes our comments on this charge question.
Thank you, Dr. Ottinger, for getting that into the record. And now we can go to our associate discussants and Dr. Fairbrother.
Yes, thank you very much. I don't have anything to add.
Dr. Johnson?
No, my comments were covered. Thanks.
Dr. Lee?
Nothing to add. Very well done job.
Excellent. Also, now the rest of the committee, any further comments on 7B2? This is George Cobb. I will just say that I think Mary Ann got saddled there with some of my catch-all comments that touched on this, but bled into other related language and documents that was found while trying to evaluate this charge question. So I appreciate you doing that. Now let's go to EPA to see if there are any clarifying questions regarding our comment.
Jim Broussard, EPA. No, we have no clarifying questions. Thank you very much.
Very nice. So thank you. And let's proceed now to question 7C1.
Jim Broussard, EPA. Charge question 7C, part 1. The draft environmental exposure assessment for octamethylcyclotetrasiloxane, D4, provides trophic transfer analysis with model D4 concentrations from COU and OESs for different media of release and exposure pathways and maximum values reported in the Enforceable Consent Agreement Report, ECA, and peer-reviewed literature for surface water, sediment, and soil. The screening level trophic transfer analysis was conducted by producing exposure estimates from the high-end exposure scenarios defined as those associated with the industrial and commercial releases from a condition of use and occupational exposure scenario that resulted in the highest environmental media concentrations. Question part 1, please comment on EPA's preliminary conclusion that D4 is likely to bioaccumulate in organisms, but not magnify across trophic levels, and therefore trophic transfer analysis is not necessary for aquatic organisms.
Thank you for getting that onto the record. And now we can turn to Dr. Johnson for as our lead discussant.
Okay, thanks, Dr. Cobb. Just so you know, I can't turn my camera on. It's been turned off by the host, and so I'll just proceed. The short answer is yes, we agree, but, and so I'll be a little more specific as I go through. Lines 1136 to 1137 in the statement from the DRE for biota, D4 is highly likely to bioconcentrate and bioaccumulate in fish, and several citations are added, is partially correct. There's considerable variability in the calculated BCF that includes exposures from water, not diet. The two references in particular, Wang et al. Cantu 2024, provided variable results. One review found that D4 doesn't bioaccumulate beyond its partitioning tendency. That's Matthews 2021. Typically, absorption in food in the intestinal tract concentrates dietary contaminants, while food digestion, for example, lipid digestion, enhances bioavailability and the chemical activity of the substance in the intestinal tract, making D4 more available for uptake and biotransformation by intestinal microbes and gastric enzymes. This suggests that the gastrointestinal uptake efficiency is low, and that's what Cantu found, that intestinal biotransformation, 63% of the dose, would negate biomagnification of D4. They also suggest that the available organic fraction of carbon explains differences between laboratory tests and field observation of bioaccumulation of D4. Therefore, I agree on the use of the BCF citing Cantu et al. 2024. However, line 641 in the draft DRE for octamethyl for D4, this suggests that Gobis et al. 2019, which is an incorrect reference for estimating fish concentrations, and agree that there is little evidence to support concerns regarding biomagnification. Moving on, EPA is correct in its preliminary conclusion that D4 will bioaccumulate and not biomagnify. This is supported by several studies, citing EPA draft physical chemistry and fate assessment for D4, pages 45 through 47. A recent review of the data from freshwater fish from Lake Pippin in Minnesota reinforces this position. That was cited in Kim et al. 2025. EPA's summary and interpretation results from these studies is logical and supported by the data. There are enough field data for D4 to have high confidence, concluding that a TMF of less than 1 in aquatic systems. I defer to Dr. Gobis. Excellent submission of the public comments why trophic transfer in aquatic systems should not be discarded simply because TMF is less than 1. The point is probably moot for human health dietary assessment if EPA defaults to using measured, not modeled fish tissue concentrations. However, for the aquatic assessment, EPA assumed that mink, piscivorous mammal, eats only fish, excluding the smaller invertebrate portion of the diet, and bases their screening assessment on modeled fish concentrations. In this case, the EPA should examine the sediment invertebrate data to ensure that its contribution to food source is in fact negligible compared to fish. Pages 43 to 44 of the draft Physical Chemistry and Fate Assessment for D4 document discusses the 6 BSAF studies that can be used to predict concentrations in invertebrates if sediment concentrations are known or modeled from water concentrations. In addition, Fremlin et al. 2021 used field measures as fugacity analysis to clearly show that BMF equals 1 in terrestrial systems. Moving on, I agree with EPA's preliminary conclusion that D4 is likely to bioaccumulate in organisms but not biomagnify across trophic levels. However, I disagree with that the EPA's implication that trophic transfer is not necessary for aquatic organisms. EPA seems to conflate the different objectives of biomagnification analysis and trophic transfer analysis. The two analyses answer different questions. A biomagnification analysis asks the relative question as we move up the food web whether organism concentrations increase or decrease along trophic levels. By contrast, a trophic transfer analysis answers an absolute question. Given real environmental concentrations in water and sediment and an organism's actual diet, what dose would a predator receive? And whether that dose is below or above its toxicity reference value. In other words, the former is about slope across the food web, and the latter is about magnitude and focal receptor. In fact, when environmental releases are high, D4 can still reach ecologically meaningful absolute tissue levels without biomagnifying. Chemical quantity will determine the solubility or determine the absolute magnitude. For this reason, I recommend that EPA should retain a streamlined scenario-based aquatic trophic transfer screen tied to the highest plausible media concentrations and site-specific bioavailability, similar to what the EPA did for the terrestrial food chain. And one other, the conclusion that D4 is likely to bioaccumulate in an organism is supported by literature as discussed. However, the conclusion that there is no magnification across trophic levels is not completely supported due to lack of data complicated by variability in outcomes from field studies. Unfortunately, this variability clouds a clear understanding of potential trophic transfer accompanied by the limitations of the analysis, specifically analysis of one further trophic level. As such, it is suggested that EPA consider models containing high trophic level predators such as scavengers, vultures, raccoons, coyotes, etc. May provide an excellent higher trophic level model, but may be only one level removed by consuming exposed fish. In addition, the use of more sensitive measures for adverse physiological effects in high trophic level receptors would indicate potential risks that may not be detected in the current approach. And that's all I have.
Thank you, Dr. Johnson. And I tried to activate your camera from this side, but can't seem to do it. So apologize for that. Oh, there we go. So let's see what our associates have to add. Dr. Ottinger?
Nothing to add. Well done. Thank you.
Dr. Fairbrother?
Yeah, thank you for that, Dr. Johnson. I think that this whole discussion about the bioaccumulation metrics or biomagnification metrics or whatever metrics gets to be a little bit conflated and confusing, as we need to really pay attention to exactly what the definition of the different metrics are. And in fact, as I was reading through question 7 to develop my responses, I had to kind of really dig in multiple times to try and extract what it was that EPA was really trying to get at with each one of these metrics. So I think that's a bit of a caveat as we kind of read through a lot and work through a lot of the responses to question 7. And I'd also like to say in response to the question about biomagnification, trophic transfer issues, that one other way to look at this and to get at this is to use the fugacity or chemical activity approach. Dr. Gobas mentioned that. I did that, and I cited a paper in one of the comments with Fairbrother and Woodburn in 2016, where we looked at that approach for D4. You could also look at a lot of the field data, some of which is admittedly from oceanic species, looking at trophic magnification or lack thereof up into some of the pinnipeds and other fish-eating species. It was done, I think, in the Norway fjord studies. Basically, all of that body of work, particularly when you start looking at the chemical activity, really shows that you don't get trophic magnification. So if that really is the focus of this particular question. I think there's a good body of data that says that while it does accumulate in organisms, it doesn't biomagnify in the food chain. Thank you.
Thank you for that. And before you go, Dr. Fairbrother, from the work you folks did with D4 and from your knowledge, do those higher level fugacity models allow different feeding strategies for the different fish species, or do you have different trophic positions that you can place your organisms in for the kinds of models that you're talking about?
Mostly what it's looking at is the potential for the chemical to actually come to equilibrium in the tissues of the organism. And so in some ways that's a little bit less important to look at where they are in the trophic levels.
Okay. All right. Thank you. And then let's see. We got Dr. Lee. Yes.
Real quick, could I ask Dr. Fairbrother a quick question and my other co-discussants? Would you say it's fair to say that we agree that it doesn't biomagnify across trophic levels? That is, it doesn't increase in concentration and body burdens across trophic levels, but trophic transfer is still a thing. Trophic transfer is still something that needs to be considered.
Could I chime in? And you brought up one of the areas that I was very interested in and wondered why those models and that approach had not been discussed relative to this charge question as well. But I think I agree with you, Dr. Johnson, Dr. Fairbrother, in terms of the interpretation. I'm still going to return back to, are transformation and metabolized products included in these models? Just asking the question.
I believe the answer to, this is Ann Fairbrother, and I believe the answer to your question, Dr. Ottinger, would be no, that it's looking at the parent product. And part of that is in the analytical work from field studies. I believe that only the parent product has been measured. And certainly when doing the fugacity analysis, it's looking at the parent product. So part of it, though, comes down to the question as to whether the metabolites are more toxic than the parent product, because sort of total chemical measurement, it's not going to be greater than if you just measure total product. But if it's more toxic, then you could have a greater response in the predator animal. So I think we need to also be careful that we don't conflate sort of hazard with exposure. And right now we're talking about exposure.
Right, exactly. And your point is well taken. And I was just responding to some papers that I cited in the other charge question that showed some biological activity for the one metabolite that's the primary one, but I'm not sure it's more toxic than D4. It's just biologically active.
Mm-hmm. So, Dr. Johnson, did that answer your question that yes, we get bioaccumulation but not biomagnification?
Yeah, I think so. I was just trying to paraphrase it to make it a little bit more straightforward for EPA.
Thanks for that good discussion. And Dr. Lee's been patiently waiting to get his responses in.
Okay, so this is Lee speaking. So actually my comments are very well covered. I don't have any additional comments, just one more very small minor point. So when we talk about bioaccumulation or biomagnification, we may be both quantitatively and qualitatively. For example, if a chemical has a BCF or BAF less than 2000, and according to EPA's hazard-based criteria, this is not a bioaccumulative. But if we just use a qualitative statement, as long as you find some gradual accumulation of the chemical in the fish, as long as you can detect a BAF or BCF greater than 1, that should be bioaccumulative. So that's why when we use this, we need to say whether we are really talking about the bioaccumulation or bioconcentration phenomenon or effect, or we are talking about the bioaccumulation or bioaccumulation according to the criteria in regulatory agencies.
Yes, thank you for that clarification. That's a good fine detail. Dr. Samuel.
Thank you. I don't have any additional comments. Thanks for the excellent summary.
Excellent. Now, other committee members, are there comments from other committee members? So this is George Cobb. I actually have one kind of follow-up, and it's not contrary at all, but it's just to point out that we mentioned the sediment invertebrates or aquatic invertebrates as a potential food source for the mink that might have higher concentrations of D4 than the than the fish, and I think that's an important aspect to capture here, and it is definitely beyond the scope of this particular assessment. But just for EPA's consideration, if you get to a situation where you have a chemical that's not biomagnifying, but is bioaccumulating, and you're trying to get to a some kind of trophic transfer analysis that may be important, as Dr. Gobus mentioned, maybe probably is important, there may be a need for a different exposure scenario where the receptor, instead of the mink, maybe there's a receptor that's something more omnivorous, like a raccoon or something that is eating primarily those invertebrates. And I'm speaking far outside of my area of expertise, talking about ecological receptors, as all of the ecotoxicologists on the group knows. But that seems like it might be something worth considering, as EPA is going to have to be evaluating many chemicals through TSCA to try to determine a different kind of model scenario when you have a compound that bioaccumulates but does not biotransfer. And maybe I'd like to ask others on the committee what they think about that. Dr. Ottinger.
I'm really glad you raised that, because I haven't mentioned, like dabbling ducks, for example, and other receptors that take in a fair amount of sediment that might be exposed, because that was not the charge question. But it's certainly a factor that could be considered. So the reason I brought up scavengers is because they're one or two more steps removed on the trophic, in terms of the trophic levels. And even if there's a minor amount of transfer or accumulation, they're the ones that are really going to potentially be affected. But the dabbling ducks, the other species that are living near the water and taking in some of the sediment as part of the food, or whatever is on the coast, it would be really helpful to at least consider them.
Yes, thank you. And I think a big thing is, are there data available for these kinds of things? I see Dr. Fairbrother and Dr. Johnson's cameras on. So do you have comments?
Yes, just following up with what Dr. Ottinger was saying is, I think you actually meant diving ducks, because they're the ones that will go down and get the invertebrates out of the sediments. Dabbling ducks tend to just be on the surface of the water and really just eat surface plants and some inverts on the surface.
Yeah, thank you.
Yeah, but I mean, that is really a good point, that if you have a chemical that doesn't biomagnify through the food web, that it could have a higher concentration in sediments and the lower part of the food web than what you have as you go up into higher trophic levels. So the mink is often selected, and I think we talk about this in the next comment, that the mink is often selected as a representative aquatic species that feeds largely on fish. The mink does take in some additional smaller amounts of its diet from invertebrates and mollusks and things like that. So you could include that. How sediment gets included, it's part of the food analysis and can either be somewhat explicitly included if you know kind of what percentage of the diet is comprised of sediment. And that is where we start getting into lack of data. So you start making a lot of assumptions as you're moving along through these food webs that you're developing to try and be more realistic. So that can add uncertainty to what it is that you're doing as you're trying to get to an analysis here.
Dr. Ottinger.
That was beautifully stated, and I really appreciate it. The other thing is tree swallows and other, terrestrial or semi-terrestrial species that live around water but eat primarily insects that are going to be exposed. That's the other kind of dimension. But we're kind of getting into these degrees of, relatedness that could pose that we don't have a lot of data for individual chemicals. So I don't want to saddle EPA with going down a rabbit hole. On the other hand, it would be nice to include these things if possible.
Definitely. I would view these as longer term goals for the agency to develop strategies for assessing chemicals of this nature, perhaps not being constrained to the mink for biomagnification, but maybe for trophic transfer where you're not expecting biomagnification. But again, I'm not an ecologist. I'm trying to let the ecologists speak.
Thank you. Agreed.
And one quick comment, because my comment button doesn't seem to be working. Dr. Lee, I added your references to the compiled version for 7B2 or B1, sorry.
Hey, thank you so much.
Okay, let's go to EPA to see if you have any clarifying. Wait, did I get all of the committee? Let's make sure that whether the committee has any additional comments. Okay, EPA, do you have clarifying questions for us?
Jim Brissett, EPA. I have no clarifying questions. I enjoyed the commentary, which includes a lot of my personal wish list to have all that data.
Well, I understand, and just so you're aware, we're not going to say that you need to do this right away. This is that long-term kind of thinking. At this point, I think just for everybody's personal comfort, let's take like a 10-minute break right now, and then we'll come back and start up with charge question 7C2. And I know I put you guys that are behind the scenes on the spot for getting that accomplished, but we can take like a 10-minute break and come back at, we can get finished up with question 7C this morning. Thank you, everyone.
Right, we have the timer for 10 minutes. Thank you.
I'm sending you the reference list.
Okay, we are back to complete the morning session of our D4 review for the Science Advisory Committee on Chemicals. This is George Cobb speaking. I see that Dr. Johnson has his hand raised.
Yeah, sorry, Dr. Cobb. I just wanted to add one experience I had a while back that was pertinent to the discussion we had before. I would just suggest that the EPA be really thoughtful about which exposure models they choose, only because I remember an example in particular with methyl mercury, where it was in a wetland, and everyone thought just by looking at the habitat that the kingfisher would be a great predator model to look at. It turns out after field evaluation, the Carolina wren had the highest exposure, and that was because it was functionally on just a little bit higher trophic level than the kingfisher was, because it was ingesting spiders that in turn were predators, right? And so I guess this gets back to the issue we were talking about before about aquatic invertebrates, and that they may have a closer interaction with the sediments, and there are several trophic levels just existing in the sediments, right? And so there may be smaller organisms on higher trophic levels than the mink. That's all. Thanks.
Excellent point, Dr. Johnson. And we've experienced similar things with mercury and with other kinds of chemicals related to ingestion of arachnids by certain avian species, especially. Dr. Ottinger.
Just reinforcing it further, we had similar experiences with tree swallows versus kingfishers for PCBs. And so, again, that's the reason for bringing up the dietary input.
Right, exactly. Okay, so now let's move on to the last part of our charge question 7.
Jim Brissett, EPA, charge question 7C, part 2. Please comment on the methods and data used for estimating dietary exposures for ecologically relevant species and discuss the appropriateness of the trophic transfer analysis for aquatic dependent mammals.
Thank you. And now we can go to Dr. Johnson once again.
All right. As mentioned previously, there's little scientific support for the biomagnification of D4, and I generally agree with the conclusions and the methods. However, I fundamentally disagree that somehow only mortality, development, and growth are exclusively populationally relevant endpoints. Line 1840. There are many examples in literature where regional variation in growth exists to allow for reduced food intake to enable reproduction, therefore growth is inhibited, yet no population level effects occur. This is adaptive and a potential evolutionary mechanism. Certainly mortality is relevant. However, for many small mammals and birds, lethargy from xenobiotic exposure can be fatal. That is, adults or offspring become easy prey if lethargic. Moreover, toxicants that influence neurotoxicity or endocrine disruption can have effects that include mate recognition, display, territoriality, and other profound ecological effects. Therefore, I suggest the EPA remain open-minded in their evaluation of toxic endpoints and consider other sublethal effects in having potential ecological significance. That stated, the use of second-generation inhalation study in rats is appropriate for use. However, it is not clear how the TRV was developed for mammals, lines 1916 through 1928 in the DRE. Suggest the EPA use the benchmark dose model to select a BMDL at the 10% level and stay away from using nulls and levels if possible. Also consider or provide a logical argument for not doing so, using the second generation inhalation study for developing mammalian inhalation TRV for burrowing mammals in functionally confined spaces where biosolids are used, for example, the short-tailed shrew. Additionally, the term ecological relevant species has not been demonstrated. Typically, ecological relevance is defined regarding their relative importance to the community or ecosystems, such as keystone species. The ecological importance of the earthworm, mink, or short-tailed shrew has not been demonstrated. However, the use of their exposure templates or life histories are conservative and representative and should be protective of ecologically relevant species in the terrestrial environment given the fate and transport and characteristics of D4. Please address the lack of concern of D4 uptake in plants, vegetables, silage, in Figure 1.4 from the biosolid application scenario. Additionally, discriminating between environmental exposures and human health appears to be separated and tends to be confusing in Figure 1.2. I suggest considering human exposures from environmental and occupational pathways and labeled ecological hazards consider environmental exposures to non-human receptors. And basically, the recommendations are really considered language changes that are more general supportive life history considerations and model selection, refrain from statements regarding ecological relevance and definitive population relevant endpoints. Consider modeling inhalation exposures to the short-tailed shrew and biosolid applications, or provide logic why it's not needed. Methods and data for estimating dietary exposure for ecological relevant species for terrestrial systems are very conservative, which is appropriate for use in a screening level assessment. The soil to earthworm, to short-tailed shrew, to carnivore, bird or mammal, pathway is a standard approach in such assessments. For aquatic-dependent mammals, the pathway is water to sediment, to chironomids, to fish, to American mink. The American mink was selected as representative worst-case exposed aquatic-dependent mammalian species. The mink became default aquatic-dependent mammals not only for its fish, crustacean, amphibian eating habits, but also because it is highly sensitive to reproductive effects of PCBs. So the most sensitive mammal in the Superfund sites, nearly which all have PCBs, even if they're not the primary contaminant of concern. Extreme sensitivity, or sensitivity likely, is not the case for D4. But for their fish eating habits and US-wide distribution make them a good sentinel species for the screening level assessment. It is easy, as well as the easy availability of data from the Wildlife Exposures Factors Handbook. Selection of the short-head red horse as a representative fish fed on mink appears to be reasonable and is likely a worst case in regard to sediment exposure. Estimating dietary exposure based on equation 5-1 in the DRE for D4 is a standard practice for wildlife risk assessments. The exposure factors in Table 5.1 and Tables 5.2 are standard for screening level assessment, although the use of juvenile feeding rates for black buffalo instead of short-haired red horse adds uncertainty. Both are in the carp family and likely have similar feeding habits. But the EPA should acknowledge the added uncertainty of the submission, especially since the lab study utilized juvenile fish. EPA's assumption of trophic magnification factor of 1 is acceptable for screening assessment. Fremlin et al. Showed that this is appropriate for terrestrial systems. The TMF equaling 1 is conservative for the aquatic scenario of sediment to chironomid fish. From chironomids to fish, Kim et al. 2025 estimated TMF between 0.1 and 0.3 for D4, but is acceptable to use it in an initial conservative screening scenario. EPA concluded that the confidence is robust for biological relevance for screening level chronic mammalian assessment, including an aquatic-dependent terrestrial species, is preceded by a very important statement that, in quotes, the resulting screening level assessment is protective. Clearly, this analysis, with all its conservative assumptions, is not predictive of mammalian wildlife exposure and risk. As long as the distinction remains clear, then the EPA can feel confident they can conclude that the mammalian wildlife are not at risk from exposure to D4. Going on, the methods and data used for estimating dietary exposures for ecologically relevant species are appropriate given the interaction and flow of D4 release from industrial and commercial conditions of use. There is going to be tremendous variability in exposure levels in the field. Accordingly, the emissions to the various areas, land, water, and air, will be variable. In addition, the issue raised in question 5 highlights the disconnect of D4 levels in water versus sediment, which could affect dietary exposures. As discussed in the previous questions, question 7CI, the trophic transfer analysis is sound based on available literature and current approaches. However, the current models and analyses include one trophic level for estimating transfer. This model ignores higher trophic level organisms and reduces the probability of detecting potential adverse effects on high trophic level organisms, including scavengers. That said, the studies used to assess the potential for trophic transfer are reasonable, with the caveat that QUI et al. In 2019 may have estimated the TMF of 1.4. There is also the question of finding from experiments using dietary administration of D4 in fish. Finally, transformation products and metabolism of D4 in the fish should be considered in any model. And that's all I have.
Thank you for getting that into the record, Dr. Johnson. And now we can turn to our associate discussants, Dr. Ottinger.
Nothing to add. Great work putting it together. Thank you.
Dr. Fairbrother.
The same. I don't have anything to add, and thank you for your good reading of that into the record.
Dr. Lee.
I don't have anything to add. Thank you.
And Dr. Samuel.
And nothing else to add from me. Thank you very much.
Very nice. So now the rest of the committee, are there other comments? Are there any comments from the rest of the committee? If not, we can turn to the EPA to see if there are any clarifying questions.
Jim Brissett, EPA. Thank you for your review and no clarifying questions.
All right. So at this point, I think I've just checked with Dr. Fairbrother that we can get through charge question 8 before we take a lunch break. So if we can get charge question 8 read into the record, we can proceed to that before lunch.
Hi, this is Chris Green with EPA. I'm going to be reading charge question 8. Within the draft environmental media and general population exposure assessment for Octamethylcyclotetrasiloxane, D4, D4 concentrations in fish tissue are calculated per specific COUs to estimate human exposure to D4 via fish consumption. Calculated D4 concentrations in fish tissue exceed U.S. monitoring data from the ECA by up to 2 orders of magnitude. In addition, the ECA's empirical fish tissue data are at least 3 orders of magnitude above measured concentrations across the available data landscape. As such, EPA believes that the maximum empirical fish tissue concentration from the ECA is an upper bound of D4 concentrations in fish tissue. EPA therefore considers all calculated fish tissue concentrations that exceeded ECA's maximum empirical value as not representative of real-world scenarios. Please comment on the appropriateness of EPA's application of that upper bound, i.e. ECA's maximum value, to define which fish tissue concentrations are realistic. Thank you.
Thank you for getting that into the record. And now we can turn to our lead discussant, Dr. Fairbrother.
This is Dr. Fairbrother reading the committee response to question number 8. Overall, in summary, the committee is in agreement that EPA should use the measured fish tissue data instead of the modeled concentration. However, the committee noted that there is uncertainty in the maximum measured value and recommends that EPA elucidate all sources of variability within field collected data. Additionally, EPA should consider the entire distribution of field collected fish concentrations and consider alternative values such as the UCL 95 instead of the maximum value. We'll now look at some specific comments. Fish concentration are calculated by multiplying modeled water concentrations by the very conservative BCF. One of the reasons that the laboratory-derived BCF is conservative is that it is based on studies with low or no organic carbon in the water. This will overestimate tissue uptake in real-world situations where the bioavailable fraction of D4 in the water is reduced due to particulate matter and dissolved organic carbon. Additionally, EPA assumed that the BCF is constant regardless of water concentration, which is not necessarily true for highly hydrophobic chemicals where the BCF will be reduced at the upper end of the exposure range. A qualitative review of the ECA study data shows that measured organic carbon in water samples spanned a 100-fold range, with some of the highest values associated with the highest reported D4 concentrations, thus significantly reducing the potentially bioavailable fraction. In addition, some of the modeled water concentrations were based on worst-case assumptions for some COUs to discharge 100% of their waste into the water, and assumed a total organic carbon equal to 5 for all receiving waters, thus resulting in a very high water concentrations. In some, the high fish concentrations are a result of multiplying very high modeled water concentrations by a very conservative BCF without accounting for bioavailability differences. So EPA is correct in defaulting to the ECA's maximum fish values for the screening assessment. Another comment, there is considerable variability in BCF values across the literature, which may be explained by the fairly unique fate and transport properties of D4 discussed previously. Additionally, controlled studies often follow the radio label, which may or may not indicate unchanged parent compound. I agree that defaulting to high-end analytical data could be useful. However, modeled concentrations that exceed an order of magnitude have been generally considered an artifact of geometric confounding of conservative criteria. Optimally, tissue data should be collected along with co-collected water and sediment samples. Lacking further data collection, I agree with EPA's decision and question the reliability of any decision based on highly uncertain modeling efforts. Going on, the decision to use field data rather than model data is generally a good idea. However, the EPA raises good points about field data not ensuring that fish were in the wastewater plumes for long duration, and the lack of matched sampling dates for water and fish and sediment. Since there is no information about fish home range relative to plume size and concentration gradients within the plume, and since foraging and contact with water could have occurred outside the D4 zone, some evaluation of uncertainty would be needed. The use of the max fish tissue concentration could be better supported by determining the UCL95 for the fish species with a max D4 concentrations across all sampling points and showing how much higher than the maximum is the UCL95. Note that this is not the UCL95 for all fish species, only for the species containing the highest D4 concentration. A factor of 10 above the UCL95 would capture the probability of the sampled fish not remaining in the plume. In essence, if the maximum is 10x above the UCL95 of the monitored data, then there would be robust evidence that the maximum is likely to capture the high end of D4 accumulation by fish. The home range and foraging strategies for collected fish species could also help evaluate the potential for collected fish to have foraged or lived in areas well away from wastewater effluent plume and mixing zones. It should be noted that all quote-unquote grab sample fish field measurements represent single points in space and time. So the only way to truly gather the desired BAF/BCF data would be to confine fish, or species of concern, in the specific area and monitor chemical concentrations in water on a semi-continuous basis or in a time-integrated fashion, not from single grab samples. Of course, such studies are much more logistically difficult and are fraught with problems that probably make the more sophisticated study designs unfeasible for the types of assessments that are needed. And another commenter, in this assessment, EPA concluded that the maximum empirical fish tissue concentration of 14.1 milligrams per kilogram should be the upper bound of D4 concentrations in fish tissue. The decision to use that maximum measured concentration as the upper bound and to define realistic fish tissue concentrations could be appropriate, given that modeled fish concentrations are so much greater than measured concentrations from the ECA and other published studies. There is some uncertainty with the concentration of 14.1 milligrams per kilogram. The concentration of 14.1 milligrams per kilogram is E-flagged and is an estimated value detected above the upper calibration flag. The data usability report states that E-flagged results are potentially biased low due to potential nonlinear response above the calibration range, page 17801 of ECA Report Volume 2. The range of D4 concentrations in fish from DD3 is 0.123 to 14.1 milligrams per kilogram, page 183 of ECA Report Volume 1. The highest concentration of D4 in fish tissue that is not E-flagged is 3.49 milligrams per kilogram, also from DD3. The ECA data should be used in this assessment to reality check modeling. Information that adds confidence to the decision to use the concentration of 14.1 milligrams per kilogram as an upper bound is that the concentration was measured in fish tissue collected near DD3, MPM Silicones, LLC, in Friendly, West Virginia, which is one of 4 industrial sites that are known D4 processors or formulators that discharge treated wastewater directly into the environment after on-site treatment. The section of the Ohio River that it discharges into is listed as impaired for bacteria, dioxin, iron, fecal coliform, and PCBs. This question also raised the issue of the use of fish in the dietary exposure for the human health risk assessment, and this comment now speaks to that as well. EPA has focused the SAC attention to the 3 sources of fish tissue concentration values and determination of maximum values from each, asking which is most, quote unquote, realistic. By realistic, we assume it means, quote unquote, representative of the maximum, and distribution, close of fish tissue concentrations in the fish likely to be eaten by the populations of interest. There are some important considerations for response to EPA's charge question. 1, the degree of differences between the calculated D4, greater by E2, and monitoring data from ECA, which is greater by E3 from other monitoring data, raises serious questions about what these data actually represent. How could these data possibly be related? Notably, the calculated D4 results include value which exceeds D4's water solubility limit, page 53, line 1364. This modeling result further diminishes the credibility of the modeling overall and lends credence to EPA's decision to exclude it from the screening purposes. EPA does choose the data provided by industry under the ECA, though that information is also incomplete and cannot be shown to be representative of the quote unquote real world scenarios contemplated by EPA. Indeed, EPA states, quote, the ECA data did not provide any additional information to crosswalk these 4 facilities to specific COUs or OESs listed in Table 1-1. The facilities monitored as part of the ECA do not represent all COUs identified in this risk evaluation either, unquote. Page 53, lines 1357 through 1359. Notably, monitoring does not seem to represent media exposed to multiple industrial sources or other reasonable complex contamination scenarios, as in, quote, real life representative environmental contaminant situations, unquote. EPA compensates for this omission by modeling the surface water based on generic scenarios with and without wastewater treatment in the assessment. Again, the EPA scientists make use of the available information as best as possible, which usually entails considering the upper end values or, quote, worst case but plausible, unquote, scenarios. Note, these are called, quote unquote, conservative by EPA, which the SAC has previously suggested strongly is a potentially confusing adjective, suggesting a mathematical descriptor such as highest plausible or maximum expected, etc., be used instead. Other data noted by EPA reports monitoring values 3 orders of magnitude lower than the ECA monitoring information. Again, such differences suggest a disconnect somehow in the compared scenarios or technical approaches. For example, the fish tissue results should reflect the size and type of fish, time in contaminated habitat, parens, factors known to greatly influence the contamination levels in fish tissue, close paren, though those variables may not have been reported and were not presented in the EPA assessment. Those details, together with description of the water body from which they were collected, even without measurement of D4 in those waters, would lend perspective to the quote-unquote representativeness of the fish collection and comparison to the D4 tissue concentrations on the distribution curve described in the ECA monitoring data. The second point, EPA's exposure assessment for tribal peoples, page 55, section 7.1.3, also raises the question about relevance and representativeness. Is the exposure calculated for tribal populations at all, quote unquote, realistic? The risk to tribal populations, section 7.1.3, reflects only exposure from fish in the diet, while recognizing many of the other sources of exposure resulting from tribal community living. No attempt was made to quantify those, in spite of EPA-sponsored information and offices where such information could be harvested with data integrity at least as good as that provided by industry on the other exposure-related values. Not noted in EPA's paragraph is the likelihood that all or nearly all dietary items would be from the same source, hence carrying the same contamination levels, unlike the quote, general population, unquote, or even foods for the subsistence fisher. Hence, tribal exposure would be enduring, repeated with each meal every day, complemented by the water drunk at those meals, and Western foods boiled or washed in that water. Many tribal water sources are not processed through purification systems, and surface water is gathered and directly consumed. EPA could have done that calculation using basic information and should at least include that with dietary exposure. As noted by EPA, tribal people are likely to bathe in that water, swim in the water, use it in artistic, workplace, ceremonial, and other activities, none of which were considered in the EPA exposure assessment. At one time, EPA was the leader in the study of environmental exposure to tribal communities and other unique communities. Tribal representatives are available to EPA via their participation in EPA forums, other divisions within EPA, and sources provided to EPA during other SAC reviews. The 7.1.3 discussion in a paragraph acknowledges some of that information without attempting any dermal exposure estimations, yielding the tribal exposure/risk assessment to be woefully incomplete. Point number 3. So for tissue concentrations, we have one set of model data, which the committee agrees is likely exaggerated and likely out of bounds for utilization, even as a maximum expected residue representation. At the other end of the spectrum, we have a collection of data which does not inform us in the EPA descriptions about parameters importantly related to fish accrual of contaminants such as D4, contamination of habitat, time in habitat, size, which tissues, which types of fish, age of fish sampled, etc. Hence, there may be some data within the collection that does reflect realistic/representative values, not necessarily maximum possible values within the scenarios of these fish exposures. However, EPA has not teased those cases out of the overall collection, which comports to the fish tissue concentrations noted in Table 7-1. This leaves the ECA data also with shortcomings as described above, but perhaps the quote-unquote least bad of the 3 data collections for seeking a quote plausible high-end unquote tissue concentration value. Note that a quote plausible high-end unquote value is not necessarily a realistic or representative value for any population groups, especially the general population. It is a convenient value to use as a screening representation where the assessment is designed to consider plausible highest exposure potential with subsequent reassessment to describe likely or representative exposure values in more refined methodologies. Also, realistic and representative infers a characteristic of representativeness. Realistic values are likely to be seen in most of the fish eaten over time, meal after meal. In the general population, the likelihood of buying fish taken from the same waters with the same exposure profile and the same kind of fish, same size of caught fish, same home waters of the fish, etc., is extremely unlikely, certainly not realistic. Hence, the high-end value from the ECA data may be in the right ballpark for a maximum plausible estimate, an appropriate value for an initial screening type assessment, but it should not be considered representative or realistic. Next point, for a representative exposure assessment to a given population, a tissue concentration that is likely to be experienced frequently, some normative value of probability of existing within the database, can be used along with other normative parameter values. Utilizing high-end values for parameters in calculation of normative, i.e. likely experienced exposure assessment, does not create a representative, realistic exposure assessment. Using high-end values to intentionally overestimate exposure as a quote-unquote corrective for some perceived uncertainty or known shortcoming will neither present a realistic assessment nor heal the potential error due to omissions or uncertainties or other problems. Finally, I cannot go without again highlighting two omissions in the D4 exposure assessment that certainly obstruct the objective of realistic exposure assessment. As noted in many previous SAC reviews, coherent calculation of all exposure opportunities with functional aggregate probabilistic models should be done to appreciate the likely risk for the general population or any significant subgroup, especially to a chemical like D4 and the myriad of daily exposures to it. Citations of those previous conversations will be included in the written response. Also, estimating dietary risk to an entire population by choosing one food is grossly insufficient. It is as if the general population dietary risk could be defined by considering only fast food hamburgers. If the fish are contaminated, so too will be tribal drinking water and all other foods irrigated by that water or harvested from the water or water's edge. Other subsistence foods feeding on these fish, shellfish, and water will carry the contaminant also. In sum, choosing a potentially too high or maybe too low value without the examination of what are representative values and the full distribution of those values, and then failure to compute the people's full daily exposure compromises the integrity of the exposure and risk assessment. Finally, in recommendations, again, the committee agreed that EPA should use the measured fish tissue data instead of modeled concentrations, but the committee noted that there is uncertainty in the maximum measured value and recommended that EPA elucidate all sorts of variability within field collected data and consider the entire distribution of field collected fish concentrations, considering alternative values such as the UCL 95. Two minor comments. Table 7-1 has a subscript in the bottom left cell that is undefined. And figure 2-1, page 43, and draft risk evaluation defines BCF as bioaccumulation factor. It should be bioconcentration factor. That concludes our comments.
Thank you, Dr. Fairbrother, for getting all of that into the record. That was quite a bit. And I know that I even left too much in my comments. There was stuff in there that I probably should have removed, and I just didn't have a chance to. So thank you very much. I think everything that you read that was mine is accurate. It just didn't necessarily need to be put on your shoulders. So thank you. I appreciate that. Now let's turn to the other discussants. Dr. Johnson.
That's all of my comments. Yeah, thanks.
Ms. Jenkins. Ms. Jenkins, are you there? She may have had to step away.
I'm
there
here.
you are.
I'm sorry. I couldn't unmute myself. Those were all my comments. I did want to make a suggestion if there are future enforceable consent agreements of this type that EPA really looks at the comments and the uses of the data so that the data are useful in this type of assessment, because it seems like that was a very major effort by these companies and EPA to coordinate that sampling. And it's it's not good that some of it may not be used. Thank you.
Yeah, thank you, Ms. Jenkins. And I totally agree with that, to get those study designs right. I'll also point out, this is George Cobb, that consent agreement was signed before the TSCA was amended. And the data came in very soon after TSCA was amended. So all of this almost predates the current TSCA that we're under, we're operating under. So that's an important consideration as well. Dr. Osmonds.
This isn't my primary expertise. I'll certainly defer to the other members. I think it was an excellent summary.
Thank you. Dr. Chason.
Thank you. And Dr. Jenkins, I agree with your comments. When the industry puts out that kind of effort, the information should have been well considered for the ultimate exposure and risk assessment. So I second those comments, and I have no others. I think that was a very comprehensive collection of our thoughts. Thanks, Dr. Fairbrother.
Thank you. And I think that's it for the committee. Excuse me, for the discussants. Anyone else on the committee have comments? I actually had one or two. So my first is more of a comment, and that is that the uncertainties that were discussed and the fact that we're left with lots of uncertainties because EPA is assuming high exposures, high water concentrations, and in this case, there's not always the need to do that, but in many cases, when we don't have information to base our evaluations on, when EPA doesn't, if there's not enough data, then we have to use conservative assumptions in the absence of data. In this case, we have some reasonable data, and the question is, how reasonable is that? I think a lot of that is captured. I just wanted to kind of circle back to that. My question to the discussants, and my thinking on this is just kind of evolving as this panel goes on, or this committee meeting goes on, is, this entire trophic transport and human exposure was based on fish, but could it or would it have been better to use shellfish? And that's not necessarily anything that can be done for this assessment, but is that the kind of thing that EPA should consider again in these kinds of scenarios, or is that not an appropriate way to go? And maybe I'll just ask that of the discussants or anybody that on the committee that has a thought about that. No response. So, okay. That's one thing that I would have thought.
This is Chris Chase, and sorry, I couldn't get my audio back on. I agree with your comment, and I would hope that at some point, EPA might reconsider, especially when you're asking for additional information. Two things, sort of the collection and the analysis be done on the most anticipated both reflect the environmental needs, multiples, what kind of extrapolations can be done for predictions for multiple species, and also how the human risk assessment will be conducted in realistic using EPA's forms. So that they're not necessarily always just calculating maximum values on top from other parameters that are valued at maximum values. The further we get away from something which is expected with whatever statistical term you want to do on a high probability that it will reoccur, might well start with what you're suggesting, Dr. Cobb, which is what would be the most revealing measurements to be made in the food chain. Thank you for that.
Yeah, thank you. Any other comments from the committee? We can turn it back to EPA to see if you have clarifying questions for us.
Hi, this is Chris Green with EPA. We do not have any clarifying questions at this time, and thank you very much for the oral report, and we're certainly looking forward to the written. Thank you.
All right. So at this point, I think it's time for a lunch break, and we have time to take an hour, maybe even an hour and 7 minutes. We'll leave that up to our DFO. I'll turn it back over to Dr. Kamal to see to get us to our lunch break.
Sure, and now it's an hour and 6 minutes, so no problem. So we can meet exactly at 1:30 Eastern time from now.
Thank you, and I look forward to seeing everyone after lunch.
All right. Enjoy your lunch.
Right. Welcome back. This is George Cobb, Chair of the EPA Science Advisory Committee for Chemicals, welcoming everyone back to our afternoon session for the review of the D4 draft risk evaluation. Before we proceed to the roll call, I'd see if Dr. Kamal has anything for us to address or information for us.
No, we're all good, so we can take the roll right now.
Thank you. Dr. Apte?
Here, I'm present.
And Dr. Baker said she would not be here. Dr. Chasen?
I'm here.
Dr. Ike?
Hello, I'm here.
Dr. Fox?
Here.
Dr. Graham? We couldn't hear you, Dr. Graham, but I can see you.
Cynthia Graham is here.
Okay. Glad to hear your voice. Ms. Jenkins?
I'm here. Thank you.
Dr. Lee?
Yeah, I'm here.
Dr. Merced Nieves?
I'm here.
Could barely hear you, but I could tell that you were there. Dr.
I'm sorry,
Ottinger?
I'm still sick, so my voice is
Oh.
coming in and out. I apologize.
Well, feel better. Dr. Ottinger?
Hi, I'm here.
Dr. Prisbilla?
I'm here.
Dr. Semmel? I see the placard, but no Dr. Semmel. We can come back. Mr. Wright?
I'm here.
All right. Dr. Fairbrother?
I'm here.
And Dr. Johnson?
I'm here also.
Dr. Osmond?
Good afternoon, present.
Dr. Rowlands? Dr. Wyckoff? And Dr. Chai?
I'm here.
Great. I'm glad you were able to join us this afternoon.
And Dr. Cobb, this is Dr. Sommel. I apologize. I'm here now.
Excellent. No, you're in time. We're just not getting through the roll. And then Dr. Rowlands or Dr. Wyckoff?
Yep.
Excellent. Thank you. Okay, so we certainly have quorum and we can proceed. Before we go too far into or any further into the charge questions, I'd like to see if there are any clarifying comments from the committee related to the things that we've discussed earlier in the meeting. I did have one question. I wanted to make sure I had clarified specifically so we can make sure it's captured, and I'm making sure it's captured properly in the written report. There was a mention in the readout that Dr. Fairbrother provided that the concentrations of D4 in fish that were used as the maximum were actually flagged as over the calibration curve. Did I hear that correctly?
I think so. This is Allison Jenkins. Yeah, I believe so.
Okay. And I didn't have a chance to delve that deeply into that part. And I just want to make sure that if that's captured, we kind of tie that back to how to handle that in relation to charge question 5. The other thing I'd like to ask the folks that were responding to charge question 8, and I should have gotten to this before we had lunch, was there was a mention of home ranges in that discussion, I believe, and in other areas of our response to other charge questions, home ranges of fish or other organisms. For the purpose of this risk assessment, do you do you think that the fish home range is an important consideration, perhaps in an uncertainty analysis or in some kind of numerical analysis? Or is that the type of thing that the field study is designed to capture in and of itself, so that while there's some uncertainty there, it's likely captured by the field study, and really looking to the ecologists to have some input there if there is any? Dr. Johnson.
Yeah, I can only speak towards terrestrial vertebrates, but typically the area, the home range is typically used to define what's known as an area use factor. And the problem with that often is the home range isn't calculated on a daily basis, right? It's a lifetime home range, and you're comparing it to a daily dose. So that the two aren't comparable. But you could, if you had specific data, if you knew about daily movements of an organism, and you knew about the extent of the contamination, you may be able to integrate an area use factor. But it's a slippery slope, and it's difficult to get to. And I don't have a clue how you would do it for fish.
Yeah, I kind of agree with you, Dr. Johnson. I just wanted to, there was talk of home range and uncertainties, and just wanted to make sure that we were as clear as we could be with that. And Dr. Fairbrother, I see your face on the screen, so please proceed.
Yeah, so I think your question was related to the fish and whether they spent a lot of their lifetime within the contaminated plume, or the area that we're assuming has the D4 in the water that then the fish are exposed to.
Yeah, should that be considered somehow, either numerically or just mentioned in the uncertainty? I remember, I think in your readout and some others, maybe on charge question 7, that home range was mentioned as one of the things that was not well considered.
And I suppose it potentially could be depending on the fish species, since we know that some fish, say salmon, for example, travel the whole length of the stream and then go out in the ocean for a while and all that sort of thing. But I don't think that was the case of the fish that were actually measured in the ECA. So we need to really drill down into what those species were. And it should be noted that some of the fish concentrations were actually composites of multiple species. Fish of a certain size were all composited together when there were small fish, which is normally done in these types of assessments. So that may confound that question a little bit more.
Yeah,
but
exactly.
Again, I think it really gets to sort of standard of practice, and also what kind of is possible from these types of field studies. You're not actually asking the question, I don't think, of exactly at point of discharge, but rather what happens when you get some dilution with the receiving waters.
Okay. Yeah. Yes. And then one final question for those in the discussants, and this is unfortunately one of the things that happens when we don't have enough time to refine our responses beforehand. But one of my comments was to figure out a UCL 95 within the feeding gill that has the highest concentration of D4 in the fish species, among fish species, and then compare that to the max value that was observed in fish, to give some credibility, or to let us have some knowledge that maximum value is in fact a maximum and not within some error bound of the feeding gill that would have the highest concentrations. I guess my question is, because that's just my comment and we didn't have much dialogue about it, or at least much email exchange about it. Is that the kind of thing that makes sense to the folks on charge question 8 or others, or is that just mathematical gyrations that aren't going to help any?
I guess I should take that one. And I really, at this point, am not sure how to answer your question. I always like to examine data in multiple ways. not the least of which is just plotting the distribution of the concentrations, maybe as a function of fish size, or something of that sort, which may or may not also be related to feeding gild. So you're kind of parsing the data. And if you don't have very much data, when you start parsing it too much, you get even less data, and that can create its own uncertainty. So it just as part of sort of the general, let's look at all the data before we really start drawing conclusions from it. I think that looking at it in multiple ways is always helpful.
Yes, and I think that's a great comment, Dr. Fairbrother, and maybe it goes back a little bit to what Dr. Johnson was saying about plotting the distributions of responses, so that you know that you're actually getting a value that is the most responsive endpoint, so to speak, or representative responsive endpoint. So maybe something like some evaluation like that would be more appropriate or more useful than this UCL comparison to the max that I suggest. I see Dr. Chason has her hand up.
Yes, I thank you for your comments, Dr. Cobb and Dr. Fairchild. I agree completely. When in other kinds of data that I've examined, when I start seeing magnitude differences in measurements like this, I also start looking for multimodal distributions, which frequently come out from lots of studies depending upon regions of collections and things like that. So I don't think that's been mentioned, but that was one of the points that I was hoping to see. And I have to admit, I didn't read every page of all this, but I didn't see any section that addressed examination of the data, as you suggest, Dr. Fairbrother. And that has come up once again in our comments previously. And I would urge EPA to discuss in these papers how they analyze the full set of the data, what the distributions look like, before just informing us as to what values that they're going to choose from a distribution to populate parameters within the algorithms. Thank you.
Okay. Any other comments from the committee? Okay, we can circle back to EPA to see if there are any updates you have for us or questions that you have for us before we proceed to our final charge question.
Jim Brissett, EPA. No, we don't have any additional clarifying questions at this time.
All right, then we can proceed to our final charge question, which is charge question 9.
Jim Brissett, EPA. Charge question 9. Within the draft environmental hazard assessment for octamethylcyclotetrasiloxane D4, EPA assigned an overall quality determination of high to a single study with relevant toxicity data of D4 exposure to freshwater green algae, Selenastrum capricornotum. Springborn Laboratories, 1990, show a 96-hour LOEC of 3.29 micrograms per liter for the growth endpoint from a single concentration. There were minor testing discrepancies where algae were subjected to constant illumination and decreases in D4 concentration during open system testing that the authors attributed to volatilization. A closed system was used to limit volatilization of D4, and it was expected to have reduced growth rates due to lack of gas exchange. Growth of algae based on cell density at 96 hours exposure was significantly, students t-test, less than the control group. However, the LOEC derived from a single tested concentration was below the EC50, And the authors did not consider this level of reduction in cell density to be representative of an adverse effect. Therefore, an algae COC based on the lower concentration is expected to overestimate risk. The overall hazard confidence for aquatic plants algae was slight due to robust confidence for the quality of the database and slight confidence for consistency, strength and precision, biological gradient and dose response, and relevance. Please comment on the strengths and uncertainties for this algae hazard value, including relevance and confidence in the hazard database for this taxa.
Thank you for getting that into the record for us. And now Dr. Fairbrother will provide our initial response.
Yes, this is Dr. Fairbrother reading in the responses from the SAC. In summary, the SAC agrees that the springborn 1990 study with the green algae Solanastrum capricornutum should not be used in the hazard assessment for ecological receptors. The SAC also has some comments about assessments of hazards to sediment organisms. Going on to some specific comments, while the species is highly relevant and the study was properly conducted following a standard protocol and appropriate QA/QC, there is little confidence in the relevance of the study results due to the reasons EPA indicated in their question. The argument that a closed system with no headspace and therefore no oxygen exchange and the test substance at its functional solubility limit is representative of a quote-unquote worst case scenario fails to consider that these factors would never occur in the natural environment. The potential for interactive effects of reduced oxygen and chemical exposure further reduces the relevance of the results, notably that growth was slower in the test system than in the open air reference flasks. The fugacity of D4 also indicates little to no uptake and toxicity by algae, as in Fairbrother and Woodburn 2016. It should also be noted that some of the fish toxicity studies were also conducted with reduced headspace and artificially high D4 water concentrations. EPA should be sure to include this in their discussion of the confidence in those laboratory studies. Another comment is that the single study in green algae provides some information. However, it is insufficient to gain an accurate estimate of potential risk or effects from exposure to aquatic organisms. The study is flawed due to restricted oxygen associated with an attempt to control D4 exposure, which then impairs growth. In addition, there were other issues with the study, such as illumination, that result in low confidence in the findings. However, it is important that studies be conducted or literature obtained that would provide information on possible effects of D4 exposure to aquatic plants, especially as these are more sedentary than fish. In summary, the study in question is not adequate for use in determining potential risk to these organisms. In further comment, Section 3.3, Aquatic Plants, of the technical support document with the draft environmental hazard assessment does not contain a table of studies or a synthesis of the body evidence, as is provided for other sections, of medium and high studies. This section begins with a statement about a single study being assigned as high quality. In trying to understand the body of evidence for this outcome, it was difficult to navigate and match studies within the data quality evaluation documentation. However, it appears there was at least one other vegetation study that was medium quality, TRAC 2018. It would be helpful to both to A, clarify if there was only one study available, or describe the body of evidence in context of the single study selected, particularly considering the potential for overestimating risk, close paren. And B, discuss if the other study or studies available inform or support the sentiment that risk is overestimated. Another comment is that further, does the lack of a case exchange due to system being closed affect environmental degradation or metabolism of D4? Was this considered in the overall quality determination? Doing studies in a closed system provides information about possible responses, but is not reflective of actual conditions. This is particularly true with studies of plants, such as algae, that will respond in similar fashion to reduced oxygen levels. In this case, the response is growth, and it is not possible to determine if the effect is due to reduced oxygen or chemical exposure or both. Regardless the effect, reduced growth, was small. In algal testing, a 50% reduction in growth is generally considered the effect, and in this test, the reduction was much smaller than that. Overall, the relevance to risk in natural conditions is questionable. And now some comments about sediments. Risk to sediment organisms is likely underestimated due to sediment concentrations measured in the ECA study exceeding the upper end of the calibration curve, albeit by an unknown amount. This compromise of the data quality leads to EPA to conclude slight confidence in the final risk to these organisms, Table 4-4 in the risk evaluation document. However, this uncertainty would result in an underestimation of the risk, so there is slight confidence that the assessment is adequately protective of ecological and human health. The SAC has repeatedly recommended that EPA specifically use language that does not equivocate regarding the direction of the uncertainty. Also, please note that stating HQs as above 1 rather than pointing out their magnitude above 1 does not adequately relay the magnitude of risks that are determined in the aquatic evaluation. Acute and chronic, and this is a minor comment, that acute and chronic toxicity thresholds, COCs, for sediment-dwelling organisms in tables 4-5 and 4-6 of the ERA report by ERM seem to be reversed, with chronic toxicity occurring at higher concentrations than acute toxicity. Please clarify and explain. This results in 4 recommendations. The committee agreed that EPA should not use the algal study in the risk assessment. The committee recommends clarifying the support documentation for this decision. The committee recommends that EPA refrain from using quote unquote conservative as an adjective in describing a risk assessment using potentially worst case scenarios. The committee recommends that EPA indicate the direction of uncertainty when using words such as slight to describe their confidence in the risk. In other words, is EPA concluding that they might underestimate or overestimate risk when they're confident in the result is slight? And that concludes our comments. Thank you.
Thank you for getting that into the record, Dr. Fairbrother. Now I'll turn to the associate discussants, Dr. Ottinger.
Very well done. I have nothing to add. Thank you.
Dr. Osmonds.
I agree with the conclusions.
Dr. Wyckoff.
Nothing additional. Thank you. Good job.
Dr. Opti.
No further comments. That was a great summary.
Thank you. Now we can turn to the rest of the committee. Are there additional comments from the committee? Okay, seeing none. I don't have any either. Let's go back to EPA to see if there are any clarifying questions for us.
Jim Brissett, EPA. I have no clarifying questions. Thank you.
Okay. So at this point, one of the things we normally do is circle back for one last pass through to see if all of the committee members have had the things they wanted to get on the record for this meeting entered. Please don't forget, if the topic hasn't been mentioned, we can't write about it. So if there's something that you even think hasn't been entered that needs to be presented here today, we need to get at least a mention of it here on the record. So open it up to the committee. Sounds like everybody's kind of, Dr. Wyckoff.
Yes. Okay. Just I don't know if eventually make a comment, but just in the purpose of getting things on the record, one of the topics just more overarching is uncertainty, and that's come up a few times in some different charge questions. And there may be it may be warranted to also give some feedback or potential suggestions on thinking about overall uncertainty, either qualitative or quantitative.
Yeah, very good comment. And that's actually one of the things we asked the agency to place in a charge question that was not then added. So I agree 100% that some overall evaluation of uncertainty is needed. And I guess maybe Dr. Wyckoff, if you have suggestions for how or where that can go, or if it goes in each section, we can work on that as we're preparing the report. I really would like that kind of thing to be in the report.
Sounds good.
Mr. Wright.
I think this was mentioned in the context of other parts of the document. But with respect to occupational data, I'd like to make sure that that this concept has gotten into the record. I think EPA, in analyzing those data, should be using the 95th confidence interval instead of the central tendency. And I guess a simple way to say that is to say that EPA's job is to protect everybody, not just half of everybody. Thank you.
Thank you for that comment. And I agree wholeheartedly with that. And the UCL 95 is not really an upper bound. It's just where we expect the mean value to be. So there are much higher exposure concentrations that you could choose than a UCL 95 or 95% confidence interval. So thank you for that comment, Mr. Wright. So Dr. Lee.
Okay, I'm just jumping because I have some sudden department commitment in 5 minutes. So I just want to mention something that Dr. Chason and I discussed through the email, and we would like to add some general comments on the PPK modeling in EPA's future risk assessment for all the lipophilic chemicals, not only specific to D4. And we highlight the need to represent the remobilization of environmental toxins during the rapid weight loss, for example, through weight loss drugs or surgery. For lipophilic chemicals that are stored in the adipose tissue, rapid lipolysis can release stored fraction from the adipose tissue to the bloodstream. And if the body doesn't efficiently eliminate these chemicals from the bloodstream, this may transiently increase the blood concentration and target organ concentration, even if the external exposure is unchanged. This remobilization can, number one, produce short-term internal dose spikes. Number two, bias steady-state assumptions used in the POD extrapolation and MOE calculations. And number three, it elevates the secondary transfer, for example, to breast milk and the co-exposure with the weight loss medications. We will share with the EPA a few publications regarding this issue. And we would also like to echo Dr. Apt's comments that EPA BPPK modeling should explicitly consider people with obesity. For lipophilic chemicals, obesity can meaningfully change the internal dosimetry. Number one, a large adipose compartment alters the volume of distribution and prolongs the elimination half-life. And number two, higher circulating lipoprotein and an expanded MLP can change the blood tissue partitioning. Number three, obesity-related physiological physiology can shift clearance and route-to-route equivalence. And number 4, dermal and inhalation exposures may scale differently with body size, skin surface microenvironments, and activity pattern. Without an obesity parameterization, adult central models are likely to under or misestimate AUCs and peak concentrations for this subpopulation. So in future assessment of lipophilic chemicals, we recommend EPA pay more attention to obesity and weight loss trajectories in chemical toxicokinetics, at least in sensitivity or bounding analysis for potentially exposed or susceptible populations. Yeah, that's everything.
Yes, thank you very much for that. And since you're one of the leads for charge question 1, maybe you weren't the lead for the actual part you were just reading in, but I'm sure you can make sure that the right people get that for their response.
Okay, for sure.
Yeah. So thank you very much.
Yeah, thank you.
And good luck with your department meeting. Dr. Opp.
Hi, I just further want to reemphasize what Dr. Lee just said. I can't believe I missed it. It's an incredibly important point with the use of GLP-1 and other weight loss drugs. There is an epidemic of that as well in our country now, and it's going to just go up. And so at this point that people will have a significant change in exposure because they go on weight loss drugs is incredibly important. And I think I'm assuming that PBPK modeling can actually be considered, can actually be used to consider that. And so that is one important thing. The other thing related to that is that as people wean off these drugs, a large number of these people will gain weight. That is something people who are studying this anticipate. And that will again change the exposure levels and depot of lipophilic compounds. And so I think going forward, EPA should consider this in their risk assessment regularly, including for D4. Thank you.
Yes, thank you, Dr. Apte. Dr. Ottinger?
And adding to that same argument, we had a brief discussion, I believe, under one of the charge question 2 areas about the lipophilic compounds and body fat and everything associated with that. But I'd like to add 2 more aspects to that. One is the mixtures of other lipophilic chemicals that are present in the fat in the body burden of people that are also going to get released at the same time. So essentially, there's an exposure to mixture, which complicates things, I'm sure, for future kinds of estimates of what an individual may be exposed to in their exposome. But the other aspect of that is the life stage effects, where there are differences in the metabolic characteristics of the individuals, and especially for women, with the loss of estrogens, which are then relevant for this and many of the other chemicals that have some endocrine effects. Those aspects need to be folded into the models.
Yes. Well stated. Dr. Samuel?
Yes, thank you. And I have a bit of background noise. I hope it's not coming through or disturbing.
It is not.
Great. So I just wanted to agree with Mr. Wright's comment regarding the use of the 95th percentile when evaluating data sets, especially relative to a known benchmark, whether that's an occupational exposure limit or, if none exists, an identified established benchmark. I think that's an important practice, and to remind everyone that there are great guidance texts available from the American Industrial Hygiene Association on that application. Thank you very much.
Thank you, Dr. Samuel. Dr. Apte, you had your hand raised. Was that an accident?
No, I wanted to make a point actually. And this kind of reflects towards indigenous populations, fish consumption, things like that, there is a significant difference at baseline in fat content, body fat content, when it comes to populations that live in colder areas. So say Alaska, for example, indigenous populations there versus those live down south. And the exposures are going to be significantly different in these cases because there is an inherent difference. This is not about obesity, inherent difference in the way these people have higher body fat. And I think when EPA does this risk assessment, that should be factored in, especially for the tribal populations who may be actually dependent on sustenance fishing for food. And so they might have a scenario, there might be that they're already at a high risk of consumption combined with high body fat content. So I just wanted to put that on the record.
Yeah. Thank you, Dr. Apte. Dr. Chasen?
Thank you. I agree with Dr. Apte. And in addition to that, the normal intake of high lipids is a characteristic, a very, very big characteristic of the diet for a large number of these people who live in the colder regions. This goes back to the comments about fish as the indicator. We've done a lot of studies. Fish is certainly not the indicator for the diet for the southwestern population. There aren't a lot of fishing villages in the deserts areas. And although fish are important in the Alaska and Northwest Territories and Canada, et cetera, the real dominant foods are the very high lipid. The high lipids, by the way, for the mammals and for the whales and things like that contain, for example, more vitamin C than any citrus fruit that we grow in terms of concentration, and a lot of the other essential nutrients, which is one of the reasons their physiology is set up such that they are very, very good at adequately handling the lipids that they're consuming, not so good at handling carbohydrates, which are certainly the basis for diets in the warmer regions. So these facts of biology and where their foods are coming from, I would hope would be adequately recognized, both in terms of the modeling, which I think is in the precipice of really getting the PBPK modeling, really getting to that level of detail and differentiation amongst the peoples, and also an upgrade in the presumptions about diet. By the way, I just wanted to mention that I know that members on this committee, but not me, are very much have published in this area of remobilization of these chemicals under certain circumstances. So I think we're very blessed to have their expertise for these kinds of comments. Thank you.
Thank you for those comments. And with my limited experience, we've done several studies where it was obvious that the lipid pool did release the lipophilic chemicals, but it wasn't necessarily in the rate that you would expect. It was very slow until it wasn't, and then it was very fast. And so those are all very interesting exposure scenarios, because you might not get what you think of as a longer term chronic exposure. You might get little, if any, exposure followed by a pulse that could be detrimental. So those are all considerations probably for future types of assessments that the agency is doing, but very important for these types of assessments nonetheless. So this is George Cobb speaking. Now, other comments from the committee? If not, I have several, and if anybody has comments while I'm speaking, please, whether they have anything to do with what I'm saying or not, These are disparate comments that kind of scatter through the document. So just bear with me, and again, chime in as you need. First of all, I have some concerns about the D4 half-life statements in the environment, specifically about the soil dissipation studies, the way they were done, and the fact that there's only one really good study and a whole bunch of other studies are just rehashes of those data. Also, those two studies use soils, one from the area where Dow actually has their primary facility in Michigan for making D4, and another remote location, not necessarily remote, but area in Hawaii that has very unusual types of soils. And the fact that you've got a study that only looks at those two types of soils, seemingly selected specifically for rapid reduction of D4 or rapid alteration of D4 concentrations in soils, gives me some pause that using those data are actually representative. Furthermore, there's some inconsistencies in the way those studies are done, or not, maybe not inconsistencies, but worrisome parts where I can't find mass balances, can't tell that D4 was not removed in the vapor phase during those studies. And I'm truly concerned that there's microbial acclimation in those soils that would be accustomed or acclimatized to D4 presence, which would increase the degradation rate of D4. Similarly, there are several, not similarly, but also there are inconsistent statements in the documents that EPA has prepared related to the persistence of D4 in sediments. In some places, it's dismissed as a very quick dissipation, and in others areas, it's mentioned that their degradation is minimal under conditions that would be present in the sediments, and that needs to be clarified. All of this will be in the written documents in our written report in more detail. There are also erroneous statements about persistence, erroneous, and they don't follow one another. Disconnected statements about the persistence of D4 in the atmosphere. The transformation rates are mentioned, and then that would lead to long-range transports by any stretch of the imagination, and those are all discounted as not being important. We have mentioned before, but I think it bears repeating, that segregating the COUs, individual COUs, and assessing risk from each one individually is only acceptable after you've done an aggregate assessment to determine what the overall risk is. And then you can do the individual COU assessment to find out where you might be able to limit exposure or limit the species that are affected so as to lower the overall risk. So you can't really do the individual COU and expect to protect the environment. You can only expect to protect the individual area that you are modeling that way. I'm just looking back through my notes, so forgive me. Also on the PBPK modeling, in some questions that were asked of the presenter, Dr. Kluo, we heard that the PBPK model could work for pregnant females if it was properly parameterized. I didn't really review that area of the report, but I still haven't heard clearly that those data exist so that that model can be properly parameterized for pregnant females, so it would be so that it could be highly useful for this kind of study and or this kind of evaluation. And I really encourage EPA to ensure that that is the case, and if not, to account for those the lack of that kind of information. So that's all I had. I want to turn it back over to the committee one more time. Do you have your hand up, Dr. Fairbrother?
I do, yeah. I also want to say thank you for that. I think that was a good addition to some of what we've been talking about today. But I also want to call to your attention for your concern about looking at degradation rates in sediments. The paper that was published in September of this year, so obviously it wasn't included in this report, it's by Kim et al. And they looked at degradation of D4, D5, D6 in sediments in Lake Pippin, Minnesota from 2011 to 2019. So that might help you with kind of corroborating some of your concerns.
Thank you for that. And honestly, a lot of my concerns about the sediment is less about the data and more about how EPA describes the degradation of sometimes it being rapid, sometimes it's unimportant, sometimes, and it depends on there's so many different documents that depending on what document you read, you get a different flavor of what that degradation is likely to be, whether it's likely to be fast or whether it's likely to not occur at all, or very limited to a very limited extent.
So it's mostly the adjectives that you're concerned about.
Yes, whether or not you're saying this is a rapid process or this process is unimportant, or those kinds of things, or it's very slow. There are those kinds of disconnects across this assemblage of documents, and it really depends on which documents you're reading. And I tend to start probably incorrectly in the fundamental data documents, and so some of those are written in ways that is not translated up into the higher level overarching documents.
Thank you for that. This is Ann. Thank you for that clarification.
Yeah, and I'll check out that paper by Kim. I haven't had a chance to read that one yet. Dr. Johnson.
Yeah, I just wanted to let Dr. Fairbrother and Dr. Cobb, that I sent Dr. Camel those references, including the one that Dr. Fairbrother just mentioned that were associated with question 7C. So they're in the mail.
Excellent. I'm sure EPA will appreciate those. Dr. Ottinger?
Yeah, I also echo what Ann and Mark have said with your effort and others on the committee to clarify many of the things that I had questions about. And one thing that I noticed and we discussed briefly was that in various draft reports, there's repeated references to the same set of literature. And so in the future, it might be helpful in the summary, the overall summary, to point out to the readers where these concurrencies lie so that we can put it all together a little more effectively for the agency. And also that will help us draw more clear conclusions and relationships between the different aspects of the study, of the review. It's just a suggestion for future.
Yeah, if that can be captured in a comment, maybe a general comment, we can certainly relay that.
Okay.
Thank you. Other comments from the committee? Okay, well, I'd like to turn it over to EPA to see, or turn it back to EPA to see if you've got any clarifying questions or answers to any questions we may have asked earlier in the week that you can relay.
Thank you. This is Chris Green from EPA. Thank you, Dr. Cobb, and thank you, SAC panel. We don't have any clarifying questions at this time. However, we do want to make sure to emphasize that the things that we're hearing across this variety of topics right now, we started to talk about PVK and other topics just recently. Obviously, just want to make sure that we're getting that in our written report so that we can, get on and address those things and see the inputs from you guys. And I think that's the answer. I think the answer is yes, but I just want to make sure.
All right. Yeah, of course, we will put this in the report. There'll probably be more in the report than EPA wants because there are several things we think need to be addressed that weren't asked of us. And so I think we've got everything handled. I would like to say thank you to everyone. I'd like to really thank our EPA colleagues for the diligent work that you're doing under much duress. And I truly appreciate the work that you're doing, and I know that the committee does as well. I'd like to thank the committee members for getting this risk evaluation reviewed in a very short time frame over some holidays. And this has been much smoother than I anticipated. And I'm very happy that this has gone as smoothly as it has. And with that, I would like to turn it over to our DFO, Dr. Kamal, to close us out for this review of D4.
Thank you, Dr. Cobb. Well, so in closing, I'd like to thank everyone who contributed to this meeting. And there is an acknowledgement slide that we can show for the team who participated in preparation for this meeting. So this team is from the Science Advisory Committee's branch. Can we show the slide? Here it is. Okay. It is from the Science Advisory Committee's branch and in EPA, and they are the ones who participated in preparing for this meeting, as well as other branches who also participated from other divisions. And in particularly the regulatory support branch for the federal notices and the communications branch for the listservs and other communications in the websites, and also the docket staff who participated in docketing all the documents that we sent. Now, thank you, Dr. Cobb, for leading this meeting and going through all the agenda items and for following FACA requirements. Thank you to the SAC committee members and the ad hoc reviewers for their input and participation in the meeting. I would also like to thank, most importantly, the OPPT team for preparing and presenting the draft risk evaluation documents and the technical support documents, and for responding to committee questions. And I want to also thank the public for listening and for presenting their oral comments during this meeting. So we ask the committee members to stay in the meeting, and everyone else can leave the meeting now, and this meeting is now adjourned. Thank you.
Thank you, Dr. Kamal.